Hello, good evening. Boys and girls, good evening. Give me the clearance. Audibility and visibility clearance, please. Hmm? Just a second, we'll wait. Now check, is it okay? Is it okay? Okay, very good. Right. So, boys and girls, very good evening from my side. Welcome to Maha revision course in the course of algorithms. I'm sure you're all doing well. ठीक है? So, आज का सेशन होगा एल्गोरिथम्स में, और जैसे मैंने पिछले क्लास में आपको बताया था कि आज भी हम विल ट्राई टू कवर इन 2 सेशन, बिकॉज एक्चुअली रिक्वेस्ट तो ये की गई थी मुझे कंपनी से कि रीशेड्यूल कर लो कोर्स आप सेशन, बट आई सेड स्टूडेंट्स के पास टाइम नहीं है ज़्यादा, सो विल ट्राई टू वर्क आउट इन 2 पार्ट्स. आज एक सेशन रखेंगे, फिर बाद में और एक सेशन देखेंगे. आगे आगे बढ़िए. Just a second, hold on for 2 minutes. Just we'll wait. I'll change the mic. माइक चेंज कर रहा हूँ, 2 मिनट दीजिएगा बच्चों. बच्चों बोलिए, इज इट क्लियर नाउ विद दिस न्यू माइक? ओके, क्लियर, वेरी गुड, एक्सेलेंट. तो चलो बच्चों स्टार्ट करेंगे सेशन, लेकिन उससे पहले एक इंटरेस्टिंग कमेंट था देव चौधरी का. देव चौधरी वाज आस्किंग मी, सर आर यू हैप्पी? व्हाई नॉट भाई, आई एम हैप्पी. Dev Chaudhary is asking, are you happy? Yes, I am happy. Why? What is the problem? What is the issue for not being happy? I am not well. I am not keeping well. That is one aspect. थोड़ा throat problem है, खांसी है थोड़ी. Okay. Otherwise, I am happy and there is no problem at all. Right? And I am sure you are also happy. आप खुश हो तो मैं भी खुश हूँ. अच्छा, हैप्पी हेल्दी पूछने के बजाय हैप्पी पूछ रहे हैं, ठीक है, कोई बात नहीं. हाँ, काफ़ी बच्चे ये पूछ रहे हैं कि टुडे सेशन विल बी इन पाइथन और सी. ये बहुत बड़ा मिसकंसेप्शन और ये बहुत बड़ा प्रॉब्लम है. स्टार्ट करने से पहले ये कहूँ मैं आपको, शायद आपने मेरा ओरिएंटेशन सेशन देखा होगा फॉर पेड बैच. ये एक बड़ा मिसकंसेप्शन है कि एल्गोरिथम्स विल बी इन पाइथन और एल्गोरिथम्स विल बी इन सी. देखिएगा बच्चों, जेनरिक एल्गोरिथम इज इन जेनरिक मोड. Algorithm is in pseudocode. There is no meaning in saying algorithms in Python or algorithms in C or algorithms in C++. ये ऐसा कोई मतलब नहीं है. आप जो भी टेक्स्ट बुक देखो algorithms की, you will find pseudocode. Pseudocode मतलब not expressed in any language. हाँ, उसके बाद आप जो चाहो लैंग्वेज में कर सकते हो, उसको कन्वर्ट कर सकते हो. You can translate your algorithm into Python or into C or into C++. जैसा हम पहले गेट डीए कोर्स आने से पहले एल्गोरिथम्स, क्या हम सी में पढ़ते थे एल्गोरिथम्स? क्या C++ में पढ़ा हमने एल्गोरिथम? नो, एल्गोरिथम इज इंडिपेंडेंट ऑफ लैंग्वेज। सो ये मिसकंसेप्शन आप अपने माइंड से निकाल लीजिए। सो यू हैव पाइथन प्रोग्रामिंग एंड यू हैव बेसिकली data structures can be in Python or data structures can be in, for example, C or C++. लेकिन data structures भी अगर आप चाहो तो independent of language पढ़ सकते हो, कर सकते हो। Okay, so we'll have discussion on pseudocode only, no nothing. और मैं यहाँ पर अब basically like महा रिवीजन कोर्स में कोई एल्गोरिथम तो डिस्क्राइब नहीं करूँगा, ये कोई डिटेल डिस्कशन सेशन नहीं है। तो एजेंडा मेरा क्या है वो हम पहले देखेंगे, राइट, फॉर बोथ डेटा साइंस एंड दिस। डेटा साइंस का जो एल्गोरिथम का है, राइट, डेटा स्ट्रक्चर्स आई मीन सॉरी डेटा साइंस का जो सिलेबस है एल्गोरिथम्स का, इट्स अ सबसेट ऑफ कंप्यूटर साइंस। तो अगर आप ये सेशन वॉच करोगे तो दैट विल बी यूजफुल फॉर योर डेटा साइंस ऑल्सो। डेटा साइंस का लिमिटेड सिलेबस है, इट्स अ सबसेट ऑफ कंप्यूटर साइंस सिलेबस। कृष्णा प्रकाश, आज की क्लास तो जनरली आई थिंक आई एम प्लानिंग बिटवीन 2.5 आवर to 3 hours एट ए स्ट्रेच। फिर उसके बाद सेकंड सेशन वी विल हैव द रिमेनिंग टॉपिक्स। 2 सेशन में कंप्लीट करने की कोशिश करेंगे। मोर ओरिएंटेशन विल बी ऑन प्रॉब्लम सॉल्विंग, रैंक थ्रू क्वेश्चंस, राइट, सो दैट विल बी आवर एजेंडा। तो चलिए बच्चों, देखिएगा पूरा सिलेबस आपका ये है, टॉपिक्स में हम कवर करेंगे। इनिशियली वी आर गोइंग टू स्टार्ट विद asymptotic analysis, a priori analysis, asymptotic analysis, and then the design strategies. So as per the syllabus of GATE, you have design strategies, divide and conquer, and greedy method, dynamic programming. 3 important strategies. Syllabus में आपके ये है. And then you have graph techniques and sorting methods as supplementary topics. So all these topics I'm going to cover as part of Maha revision in 2 parts, in 2 sessions. आज का एक सेशन होगा. Most probably we'll try to cover up asymptotic analysis, divide and conquer, and if possible greedy method आज के सेशन में कंप्लीट करेंगे. फिर उसके बाद हम काफी क्वेश्चंस है। राजेश बोनिया, यू हैव ए पेशेंस, आप यहाँ पर देखिएगा। Krishna Prakash is saying, I don't know concepts of algorithms. Can I watch this? You can try, Krishna Prakash. I cannot say don't watch. आप try कर सकते हो, कोशिश कीजिएगा. If you are able to follow, well and good. If not, then you can leave. There is no problem. क्योंकि ये revision session है. This is basically a revision session. ठीक है? So I'm expecting that you know algorithms. आपको कुछ पता हो, क्योंकि हम डीप डाइव कॉन्सेप्ट्स में नहीं जाएंगे, डीप डाइव नहीं करेंगे, हम बेसिकली सुपरफिशियल तरीके से कवर करेंगे, एज इफ यू आर प्रिपेयरिंग, मेकिंग योर फाइनल प्रिपरेशन फॉर योर गेट एग्जाम। ठीक है? यस, या आई एम स्लाइटली स्टिल नॉट वेल गोपाल कुमार, आई मीन थ्रोट का प्रॉब्लम है एंड स्लाइट कंजेशन इन दी चेस्ट लाइक दैट, ओके, बट स्टिल नो प्रॉब्लम, आई कैन मैनेज द क्लास फॉर सम टाइम, कीपिंग इन व्यू ऑफ योर प्रायोरिटी, ओके। तो बच्चों देखिए, यहाँ पर सिलेबस भी मैं डिटेल में आपको लिख रहा हूँ, सो दैट यू कैन कम टू नो व्हाट टॉपिक्स आर वी सपोज टू प्रिपेयर। लाइक एनालिसिस ऑफ एल्गोरिथम्स में दीज आर द टॉपिक्स यू हैव टू फोकस ऑन, राइट, लाइक कॉन्सेप्ट ऑफ एल्गोरिथम, लाइफ साइकिल स्टेप, नीड फॉर एनालिसिस, टाइप्स ऑफ एनालिसिस, मेथोडोलॉजी ऑफ एनालिसिस, राइट, एंड देन यू हैव asymptotic notations, very important part for analysis of algorithms. Then you have properties of asymptotic notations, framework for analyzing recursive algorithms, non-recursive algorithms, फिर loop complexities, right? And then analyzing loops, etc. Space complexity, mathematical background है, problem solving. So detailed syllabus है ये. उसी तरह divide and conquer का detailed content है यहाँ पर, आपने जो prepare करना है. These are the important topics that you should prepare for divide and conquer. उसी तरह greedy method देखिएगा, greedy method के topics है. All the problems, applications of greedy method जो आपने prepare करना है. Then like that, dynamic programming, these are the topics that you should prepare fully as far as GATE exam is concerned, right? Then topics to be covered under graphs, graph algorithms, ठीक है, जहां पर हम बात करेंगे डेप्थ फर्स्ट सर्च एंड ब्रेड्थ फर्स्ट सर्च की. फिर उसके बाद सप्लीमेंट्री टॉपिक्स है, हीप एल्गोरिथम्स. जनरली मैं जब एल्गोरिथम फुल कोर्स पढ़ाता हूं पेड बैचेस में, then I make sure that I cover heap algorithms also. Yes. Then you have hashing. Hashing generally will be covered in data structures. फिर उसके बाद देखिए sets actually not mentioned in the syllabus, लेकिन जब आप क्रुस्कल्स एल्गोरिथम बाई कनेक्टिविटी की बात करोगे वहां पर सेट डेटा स्ट्रक्चर्स यूज होता है। तो जनरली मेरे अपने पेड बैच में स्टूडेंट्स को मैं सेट्स के बारे में भी पढ़ाता हूँ, व्हाट आर सेट्स, हाउ आर सेट्स रिप्रेजेंटेड एंड व्हाट आर द ऑपरेशंस ऑन सेट्स। तो ये सिलेबस यहाँ पर रखने का मकसद ये है कि आप जब फुल फ्लेज कॉम्प्रिहेंसिव प्रिपेयर कर रहे हो एल्गोरिथम्स में, ये सारे के सारे टॉपिक्स आपने प्रिपेयर करना है। लास्ट है सॉर्टिंग एल्गोरिथम्स, टर्मिनोलॉजी, बेसिक टर्मिनोलॉजी, मेथड्स एंड प्रॉब्लम सॉल्विंग। तो बच्चों ये हो गया है डिस्कशन विद रिगार्ड टू सिलेबस। और जो टेक्स्ट बुक्स अगर फॉलो करना चाह रहे हो आप एल्गोरिथम्स के, तो साहनी टेक्स्ट बुक है, कॉर्मन टेक्स्ट बुक है, you can follow any of these two textbooks. Corman is generally considered to be one of the very acknowledged internationally followed textbook Corman के लिए। हाँ, नोट्स ग्रुप पे आप पूछ सकते हो, ग्रुप में आपको टेक्स्ट नोट्स मिल जाएंगे। हाँ, शुभम शास्त्री गेट डीएस सिलेबस बेसिकली concentrate on only a few areas like analysis of algorithms, then divide and conquer, then you have basically sorting methods, graph techniques, that's it. These are the topics for GATE DS syllabus. तो आप एनालिसिस का डिस्कशन कर लीजिएगा, डिवाइड एंड कॉन्कर का भी आपको डिस्कशन मिल जाएगा आज की क्लास में। सो दैट विल कंप्लीट वन पार्ट फॉर योर गेट डीएस सिलेबस। यस कृष्णा प्रकाश, आई विल ट्राई टू टच अपॉन इंपॉर्टेंट टॉपिक्स। जैसे हम टॉपिक्स proceed करेंगे, as we proceed with the syllabus, we will try to cover up. I will tell you what are the important topics. Please आपसे गुजारिश ये है, right? आपसे गुजारिश ये है कि unnecessary comments और unnecessary discussion में मत जाइएगा. Try to follow carefully, try to follow patiently, and utilize the session. That is what is my appeal, and I request you for that. Okay? So thank you so much for your patience. And we'll try to cover up here. Okay, so let's see here. Asymptotic analysis. और इसमें सबसे पहले we'll start our discussion with the algorithm concept. Right? The concept of algorithm and life cycle steps. Yeah, Rajesh Boina, I will also try to use English because the course is in English mode. That's why I will try to use English, Hindi plus English both. I will try to use English also, no problem. In this session, Vinay will not cover sorting. In the next session, we'll cover sorting, right? Try to follow. This will also be very useful. Today's session will be totally useful for GATE DS students also. GATE DS students के लिए भी ये session काफी important है. So please follow carefully. चलिए, right from scratch, we'll start. Algorithm. What is algorithm? What is the formal definition of algorithm? Algorithm हम ये कहते हैं कि is a solution for a problem. So generally we are having a problem P. The problem could be a computer related problem, non-computer related problem, engineering problem or science problem or mathematics problem. हर problem का statement होगा. Every problem will have a statement. So the solution for the problem is called algorithm. And the concept of algorithm is not new to mankind. Right from existence of human race, हम बोलेंगे कि we have the algorithm concept. Right from prehistoric age, where man was assumed to be living in caves. जो भी आप procedure follow करोगे for achieving your task, solving your problem, that is called algorithm. लेकिन relatively, the concept of algorithm, computer-based algorithm, is relatively new to mankind. और जब भी अब आज के बाद से और अब के बाद से जब भी हम एल्गोरिथम बोल के बोलेंगे तो वी आर रेफरिंग टू ए कंप्यूटर बेस्ड एल्गोरिथम विच वाज नेम्ड आफ्टर ए फेमस पर्शियन साइंटिस्ट, Iranian साइंटिस्ट, मैथमेटिशियन by name Muhammad al-Khwarizmi. The name algorithm came from his name al-Khwarizmi. So what is a formal definition of algorithm? Algorithm consists of finite set of steps to solve a problem. देखिएगा, consists of finite. I cannot have infinite steps. Finite set of steps in order to solve any problem is called algorithm. ठीक है? Then comes हम यहाँ पर बोलेंगे generally every step you can also call it as statement. A computational statement could be like C is equal to A plus B, or it could be a loop, for example, for I is equal to 1 to n, or it could be a normal function call, for example. ठीक है? These are the examples of steps or statements. every statement or every step of an algorithm consists of, every statement or step consists of one or more basic operations, fundamental operations, primitive operations like addition, subtraction, multiplication, etc. Each statement or each step of the algorithm consists of one or more basic operations. Like अगर आप यहाँ पर देखो ये statement में, what are the basic operations? The basic operation is addition, assignment. So example of basic operations could be like arithmetic operations, logical operations, relational operations, assignment operations. ठीक है? These are the basic operations. So every statement, high level statement of an algorithm involve one or more basic operation. ये basic operation play a very crucial role in analysis of algorithm. जब आप analyze करोगे algorithm को, it will be dependent on this basic operation. ठीक है? That's why we are talking about it. Every algorithm may accept 0 or more inputs, but must produce at least one output. So this is the formal definition of algorithm. अब next बात होगी life cycle steps. Generally, what are the life cycle steps? Generally, what is the step-by-step procedure that we follow for algorithm development? तो जैसे मैंने कहा, first you define the problem. देखेंगे step 1 से problem definition. Problem definition के बाद you determine the requirements. Requirements are also called conditions. और algorithmic philosophy में you can also say constraints. हर एल्गोरिथम के अपने कंस्ट्रेंट्स होंगे, कंडीशंस होंगे. ठीक है? यू डिटरमिन दैट कंडीशन. देन थर्ड स्टेप इज यू थिंक ऑफ द लॉजिक. यहां पर आपका डिजाइन का कॉन्सेप्ट आएगा, एल्गोरिथम डिजाइन. यू थिंक ऑफ द डिजाइन, यू थिंक ऑफ द लॉजिक. उसके बाद यू एक्सप्रेस योर एल्गोरिथम, डेवलप योर एल्गोरिथम. तो जहां अब यहां पर जब आप डेवलप करोगे, you need not develop in any language. You can develop using your own normal English statements. That is development. Yeah, you can also say it's like SDLC. Exactly correct. Prajapati, Shubham Prajapati is like SDLC. So you develop the algorithm. So यहाँ पर algorithm development होगा. उसके बाद क्या करोगे आप? Algorithm को validate करोगे. Validate. Proving is correct or incorrect. Validation. Validation के बाद you go for analysis. तो यहाँ पर हम बात करेंगे why should we analyze. Shortly we'll take up the discussion. What is the need for analysis? Why should we analyze? फिर उसके बाद होगा implementation. You here now you can take the software and hardware as far as implementation is. यहाँ पर आप कोई programming language लीजिएगा, C लीजिएगा, C++ लीजिएगा, या फिर Python, whatever language of your choice. Implementation. Then you go for testing and debugging. These are the steps. These are the steps. तो बच्चों ये कहना है कि among all the steps, as far as this subject is concerned, this course is concerned, our objective is to study about various design strategies and analysis. Design and analysis of algorithms. That is why आपके कॉलेज में या यूनिवर्सिटी में full name जो होगा कोर्स का वो DAA कहते हैं generally. DAA. Design and analysis of algorithms. Right? Because for solving a problem, I can have multiple strategies. Generally, I used to tell like sorting is a problem. आपको पता है n number of sorting techniques we have: selection sort, bubble sort, and then insertion sort, merge sort, quick sort. So many sorting techniques. हर sorting technique की अपनी strategy है, अपना approach है, अपनी design method है. So over a period of time, researchers and developers of this field have categorized some standard design strategies. एक design strategy का मतलब है greedy, एक है divide and conquer, एक है backtracking, एक है branch and bound, dynamic programming, and so on. This strategies है. तो जब भी कोई प्रॉब्लम आप सॉल्व करना हो, you have to think of that. Can I solve it using greedy method? Can I solve it using backtracking? Can I solve it using dynamic programming, and so on? So that is the design strategy. और naturally जब आप डिजाइन कर लोगे एल्गोरिथम को, तो फिर आप बात करोगे सर हम एनालाइज क्यों करें? What is the need for analysis? तो चलिए अब यहाँ पर आएंगे क्वेश्चन. Why should we analyze? What is the need for analysis? Why should we analyze the algorithm? It's very simple. Just now I said that a problem P can have multiple algorithms. I have algorithm A1, I have algorithm A2, I have algorithm A3. I can have multiple solutions. Solution 1, solution 2, solution 3. Obviously बच्चों, जब कोई प्रॉब्लम के मल्टीपल सॉल्यूशंस होंगे तो हम ये क्वेश्चन हमारे माइंड में आएगा कि कौन सा सॉल्यूशन बेस्ट है, which is efficient solution. Which is efficient solution? So among the following three algorithms, which solution is superior, which solution is better? All right? Which solution is better, which solution is efficient? दैट वी हैव टू डिसाइड। तो उसके लिए हमें कंपेयर करना पड़ेगा एल्गोरिथम्स को, दैट इज कॉल्ड परफॉर्मेंस कंपैरिजन। So the first need for analysis is to make comparison among different algorithms to find out which algorithm is best efficient. और जब आप परफॉर्मेंस कंपैरिजन करोगे, you will have to always compare them with respect to some performance metric. चलिए यहां पे लिख रहा हूं मैं, परफॉर्मेंस मेट्रिक। परफॉर्मेंस मेट्रिक कोई भी एक मेट्रिक से आप कंपेयर करोगे ना, जैसे कि फॉर एग्जांपल यू से टाइम एंड स्पेस, वेरी गुड, टाइम एंड स्पेस, these are performance metrics, and in general we call them as resources. These are resources of the computer system, time and space, time of CPU, space of memory. तो यहां पर वही रीजन बताया गया है, देखिएगा, the basic objective, the basic reason for analysis is to make performance comparison, among different algorithms to find out which is the superior or efficient algorithm. And to carry out that performance comparison, we should carry out with respect to some metric or resource. So therefore, people say that fundamentally there are two reasons for doing analysis. Number one, to determine resource consumption, matlab to determine the time of each algorithm, to determine the space requirements of each algorithm, A1, A2, A3, and then after that you make performance comparison among them to decide which is superior or efficient algorithm. So this is the question of what to analyze and why should we analyze. तीन questions है बच्चों, तीन keywords है, what, why and how. What to analyze, why should we analyze, and finally obviously जब what और why का हो जाएगा तो next question क्या आएगा, मुझे लिख के बताइएगा please. After addressing the question of what, why, what should be the next? Come on. Obviously क्या होगा question? How, exactly correct. How to analyze, methodology of analysis. How to analyze का मतलब है methodology of analysis. So that is the most important thing. That is one of the important topic of this chapter. How it should be analyzed. कैसे करेंगे analyze? Tell me quickly in the chat box what are the different methods of analysis. Come on. What are the different methods of analysis? बोलिएगा. It's there on the slides, you can check. What is the method of analysis? Methodology. So this is addressing the question of how. So आपने remember किया होगा, you are able to remember there are two methods. One is called a posteriori method, the other is called a priori method. Yes, very correct. Many people are telling the answer. A posteriori and a priori. A posteriori analysis is platform dependent analysis. Platform dependent analysis. प्लेटफॉर्म का मतलब यहां पर दो चीजें हैं, हार्डवेयर एंड सॉफ्टवेयर प्लेटफॉर्म। आपने कोई एक कंप्यूटर लेना होगा, मशीन, प्रोसेसर, मेमोरी, आईओ डिवाइसेस एक्सेट्रा, कोई लैंग्वेज सेलेक्ट करना होगा, कोई ऑपरेटिंग सिस्टम सेलेक्ट करना होगा, एंड देन यू आर गोइंग टू राइट द प्रोग्राम, implement it and execute it on the system and physically determine, manually determine what is the time and space requirements. This is called a posteriori method of analysis. इसका advantage ये होगा कि you will get the real time in real units, actual time in real units. कितना टाइम लगेगा? 2.5 millisecond for example, 10 millisecond for example. Real time you will get, real time, actual time in real time units. ये advantage. लेकिन बच्चों इसका ड्रॉबैक है, a posteriori method of analysis का ड्रॉबैक ये है कि it is difficult to carry out, it is not easy, it is just like conducting an experiment, ठीक है, तो it is not easy to carry out. लेकिन second drawback is more severe, जिसकी वजह से हमें a priori analysis पे जाना पड़ेगा. Second drawback of a posteriori analysis or platform dependent analysis is that, second drawback ये है कि remember, different people may execute their programs on different platforms. मैं कोई platform पे execute करूँगा, आप कोई करोगे. Then when I have non-uniformity of platform implementations, तो हमारा result भी अलग-अलग आएगा, right? So it may be possible that an inefficient algorithm may run on a faster machine and take less time, and an efficient algorithm may run on a slower machine and may take more time, unfortunately. So non-uniformity होने की वजह से I may get different results, और जब different results आएंगे, different platforms होंगे, तो it become difficult for me to make performance comparison. So बच्चों, बात समझने की ये है कि a posterior analysis no doubt will give you the real value, but the drawback is it is not uniform. Non-uniformity will lead to difficulty in non-uniformity will lead to difficulty in making performance comparison. Performance comparison करना बहुत मुश्किल होगा यहाँ पर when you are implementing it with real platforms because of non-uniformity. तो उसके लिए you have to go for a system or an approach which should be independent of platform independent analysis. That means without implementing the algorithm on using language or running it on the machine, just on a piece of paper, writing the algorithm with a pen or pencil, you are going to determine, you are going to perform analysis, right? So that is called a priori analysis. This is platform independent analysis. चलिए अब यहाँ एक क्वेश्चन पूछ के देखूंगा, What is the basis of platform independent analysis? क्या मुझे कोई बताएगा चैट बॉक्स में? How is algorithm analyzed in a priori mode of analysis? A priori mode में कैसे आप एनालाइज करोगे? What is the fundamental basis, fundamental working principle of a priori analysis? बोलिएगा, देखेंगे कौन बताएगा आंसर. Yes, it is based on what? Yeah, time and space you determine through a priori analysis, but how? Before implementation होगा, कैसे करेंगे आप, कैसे करोगे? On the basis of input. ठीक है? Okay, that is one point. It is with respect to, you are determining the time with respect to input, that is correct. But what is the basis? Basis is, remember, two things. Either you say order of magnitude of statement, order of magnitude of statement or step, or you can say step count. Make a step count. Make a step count. Simple example लेकर समझा दूंगा आपको, even though it's a sort of revision. Suppose, for example, if I have a statement like x equal to y plus z, and I have another statement, for example, for I is equal to 1 to n, and I write a statement like a is equal to b plus c, something like that I'm writing, something. And I have another loop for I is equal to 1 to n, and then for j is equal to 1 to n, I write k is equal to k star m, something like this, hypothetical statement. I'm assuming this is some algorithm will name it as ABC. तो बच्चों ये कह रहा हूं मैं यहां पर देखिएगा, this you need not write in Python, you need not write in C. That is what I said. There is nothing like algorithms in C, algorithms in Python. ठीक है? So this is the paradigm. I have step 1, step 2, step 3. So I want to know what is the time in a priori method of analysis. दो अप्रोच से हम कर सकते हैं. एक अप्रोच है स्टेप काउंट, दूसरा अप्रोच है ऑर्डर ऑफ मैग्नीट्यूड. स्टेप काउंट का हम देखेंगे यहां पर. स्टेप काउंट का मतलब यह है, वन स्टेप इज नथिंग बट इक्वल टू लाइक वन प्रिमिटिव ऑपरेशन, वन बेसिक ऑपरेशन. So we assume that each of these basic or fundamental or primitive operation, as per a priori mode of analysis, each basic operation or primitive operation take 1 unit of time on our hypothetical computer, unit of time. These independent of units, 1 unit, मतलब addition हो, subtraction हो, multiplication हो, division हो, comparison हो, assignment हो, all fundamental operations will take just 1 unit of time, just 1 unit of time. Right? So therefore every fundamental operation. तो हमें क्या डिटरमिन करना है? हमें सिर्फ इतना डिटरमिन करना है कि हर एक स्टेटमेंट में कितने फंडामेंटल ऑपरेशंस है, टोटल काउंट आपको डिटरमिन करना है. दैट इज कॉल्ड स्टेप काउंट मेथड. मतलब अब जब यहाँ स्टेटमेंट देखो, ये एक फंडामेंटल ऑपरेशन है, ये फंडामेंटल, तो हम बोलेंगे दिस स्टेटमेंट टेक 2 यूनिट्स ऑफ टाइम. 2 इज अ कांस्टेंट, 2 इज ए कांस्टेंट. यहां पर आप स्टेप्स देखिएगा, इनिशियलाइजेशन है, then comparison hai, increment operation hai, addition hai, this. So if you add up all that, 1 initialization, n plus 1 comparisons, n increments operations, right? And then I have n additions plus n assignments. This become your total step. 1, 2, 3, 4. 4n plus 2 bolenge hum. Total step count. Total step count is 4n plus 2. यहां पर अब समझने की बात यह है कि what is n? N is input. Let me write. What is n? N is generally input size of input. तो मतलब ये हुआ कि ए प्रियोरी मोड ऑफ एनालिसिस में यू आर गोइंग टू कैलकुलेट द टाइम विथ रिस्पेक्ट टू इनपुट साइज विथ ए सिंपल कन्वेंशन दैट जैसे जैसे इनपुट साइज इंक्रीज होगी तो टाइम भी इंक्रीज होगा। तो आप वो रेट ऑफ ग्रोथ ऑफ टाइम डिटरमिन करोगे, रिप्रेजेंट करोगे बाय मींस ऑफ अ मैथमेटिकल फंक्शन। लाइक हम बोलेंगे लीनियर ग्रोथ 4n+2 ऑर्डर ऑफ n। सो ऑर्डर ऑफ मैग्नीट्यूड ऑफ दिस स्टेटमेंट इज सेड टू बी ऑर्डर ऑफ n। ये फंक्शन का ऑर्डर क्या है? ये फंक्शन का ऑर्डर है ऑर्डर ऑफ n। ऑर्डर ऑफ मैग्नीट्यूड इज n। उसी तरह ऑर्डर ऑफ मैग्नीट्यूड ऑफ दिस स्टेटमेंट विल बिकम हाउ मच? n²। एक्चुअल फंक्शन आएगा समथिंग लाइक 4n² + 4 8n+4 समथिंग लाइक दैट। और वो फंक्शन का ऑर्डर अगर आप लोगे तो n² होगा। तो ऑर्डर ऑफ मैग्नीट्यूड ऑफ दिस स्टेटमेंट, अगर ये कांस्टेंट फंक्शन का ऑर्डर अगर आप लोगे तो 1 होगा। दिस n, दिस n²। तो तीनों फंक्शंस को अगर आप ऐड करोगे देन दैट योर कंसोलिडेटेड टाइम, टोटल टाइम विल बिकम 1 + n + n²। टाइम फॉर स्टेप 1 + टाइम फॉर स्टेप 2 + टाइम फॉर स्टेप 3, तीनों का टाइम ऐड किए। इसके बाद मैथमेटिक्स में एक कॉन्सेप्ट है जिसका नाम है ऑर्डर ऑफ मैग्नीट्यूड ऑफ एनी फंक्शन। ऑर्डर ऑफ मैग्नीट्यूड ऑफ एनी फंक्शन इज ऑर्डर ऑफ दैट टर्म, लीडिंग टर्म इन द फंक्शन ऑफ हाईएस्ट डिग्री और हाईएस्ट वैल्यू। तो ये टर्म्स में हाईएस्ट डिग्री और हाईएस्ट वैल्यू टर्म क्या है? n²। तो मैथमेटिकल नोटेशन में हम जो अब इंट्रोड्यूस करेंगे हम, वी राइट दिस एज ऑर्डर ऑफ n² फॉर नोटेशनल कन्वीनियंस, indicating that the maximum time taken by this algorithm, upper bound time taken by this algorithm is order of n²। तो बच्चों बात ये है कि in a priori mode of analysis, listen to me carefully, the objective of a priori analysis is to represent the time complexity, is to derive the time complexity with respect to input size, generally n, with a normal convention or a normal understanding that as the size of input increases, जैसे जैसे आप input size increase करोगे time भी increase होगा। तो आप वो जो rate of growth of time है with respect to input, you are trying to represent it by means of a mathematical function। ये क्वाड्रेटिक ग्रोथ है, उसी तरह लीनियर ग्रोथ होगी, लॉगरिथमिक ग्रोथ हो सकती है, एक्सपोनेंशियल ग्रोथ हो सकती है, कांस्टेंट ग्रोथ हो सकती है। तो दैट इज द नटशेल डिस्क्रिप्शन ऑफ ए प्रियोरी एनालिसिस इन समराइज फॉर्म। Objective of a priori analysis is to represent the time by a mathematical function, right, of input size with respect to input size। ये है basic funda of a priori analysis। तो based on this, यहाँ पर समराइजिंग तरीके से आपको लिख दूं एक पॉइंट कि time in a priori mode of analysis is represented by means of a mathematical function with respect to input size, say n। ये जो फंक्शंस है, जनरली दीज फंक्शंस कैन कम इन डिफरेंट फॉर्म। शायद फंक्शन लॉगरिथमिक हो, या फिर पॉलिनोमियल हो, और फिर एक्सपोनेंशियल हो। इट कैन बी पॉलिनोमियल, इट कैन बी लॉगरिथमिक, और इट कैन बी exponential। Logarithmic, like for example, it can be log n। Polynomial may be like n or n² or something we write in short n power x. X is a constant greater than or equal to 0. Or it can have an exponential rate of growth, like for example a power 2 power n, 3 power n, 4 power n, in general n power n. Like you can write a power n where I say a is greater than 1. So I can get the time complexity of my algorithm in a priori mode either by means of a logarithmic function or a polynomial function or exponential function। अब यहां पर आपने बताना है मुझे which rate of growth, polynomial or exponential। Generally logarithmic will have lesser rate of growth than polynomial, तो हम logarithmic को polynomial की कैटेगरी में ही enclose कर लेंगे। तो आपने मुझे बताना है an algorithm having which rate of growth, polynomial or exponential, is desirable। जो भी प्रॉब्लम के लिए आप एल्गोरिथम डेवलप करें, which rate of growth is desirable for an algorithm for a given problem, polynomial or exponential? Come on, always tell me which algorithm is efficient, algorithm having polynomial rate of growth or exponential rate of growth? In general, Nishu Kumar is saying exponential. Is it exponential? Exponential have super high rate of growth, higher rate of growth. They are higher rate of growth। Higher rate of growth का मतलब है algorithm will take more time, means algorithm will be slow। Polynomial is having slower rate of growth, polynomial and log, slower rate of growth. Slower rate of growth means algorithm run fast. They take less time. So therefore, it is always desirable that you develop algorithm for problem having polynomial rate of growth. Polynomial rate of growth is supposed to be efficient algorithms. लेकिन अब उसके पीछे एक theory है. There is a lot of theory. There is a lot of stuff there as part of your complexity theory that you have to basically make a study. जहाँ पर बात होती है categories of problems. Some problems have polynomial rate of growth. Others have only exponential rate of growth, right? And some does not have any algorithm. So such problem for which there is no algorithm, they are called undecidable. So that is all about intractability complexity theory. वो हमें algorithmic perspective से नहीं जाना है. आप theory of computation में generally पढ़ते हो. Rate of growth का मतलब है damn. Rate of growth का मतलब इनपुट साइज जैसे जैसे आप इंक्रीज करोगे तो टाइम कैसा इंक्रीज हो रहा है. इट इज वेरी ऑब्वियस ना. समझने के बाद समझने के लिए बहुत आसान है कि जैसे आप इनपुट साइज इंक्रीज करोगे 10 एलिमेंट 20 एलिमेंट 50 एलिमेंट 100 एलिमेंट्स 200 एलिमेंट्स, जैसे जैसे आप इंक्रीज करोगे टाइम भी इंक्रीज होगा. ये प्रोसेस को रेट ऑफ ग्रोथ बोलते हैं. कैसा ग्रोथ हो रहा है रेट. डज इट फॉलो ए लीनियर ग्रोथ, क्वाड्रेटिक ग्रोथ, क्यूबिक ग्रोथ, लॉगरिथमिक ग्रोथ, एक्सपोनेंशियल ग्रोथ, ये मतलब है. चलिए अब आगे बढ़ेंगे बच्चों. सो ये भी डिस्कशन हो चुका. सो वी ऑलवेज एक्सप्रेस बेसिकली algorithm having polynomial rate of growth than exponential because polynomial have lesser rate of growth than exponentials. चलिए नेक्स्ट है देखिएगा बच्चों, as part of a priori analysis something called behavior of algorithm or types of analysis. Second part of a priori mode of analysis is behavior of algorithm or types of analysis. So one part of a priori analysis is determining the rate of growth. कि जैसे आप इनपुट साइज इंक्रीज करोगे तो टाइम कैसे इंक्रीज हो रहा है. नाउ सेकंड पार्ट ऑफ ए प्रियोरी एनालिसिस इज नाउ वी आर नॉट इंक्रीजिंग द इनपुट साइज. वी से दैट फॉर ए फिक्स्ड इनपुट ऑफ साइज n, फॉर ए फिक्स्ड इनपुट ऑफ साइज n, 100 एलिमेंट्स ले लो आप या 200 एलिमेंट्स ले लो, फिक्स्ड इनपुट साइज, आई कैन हैव डिफरेंट परम्यूटेशंस ऑफ द इनपुट्स. शायद मेरा इनपुट इंक्रीजिंग ऑर्डर में हो सकता है, डिक्रीजिंग ऑर्डर में हो सकता है, या रैंडम ऑर्डर हो सकता है, पार्शियल इंक्रीजिंग, पार्शियल डिक्रीजिंग, या ऑल एलिमेंट सेम, समथिंग लाइक दैट. So for different input classes, these are called input classes: increasing order, decreasing order, random order, etc. So for different arrangements of inputs, it is quite of same size n, for same size n, different arrangement for different input classes, it is possible that the algorithm may have different behavior. शायद कोई algorithm ज़्यादा time ले for one input class and may take less time for another input class. जैसा कि for example linear search है, it will work if the first element is found at the first place, so it will take less time. Agar if the element is found at the last place, that is another input class, it will take more time. So these are called input classes. And that determining the different input classes and finding out what is the minimum time algorithm take, maximum time algorithm take, that is basically called behavior of algorithm or types of analysis. So bachcho, I would like to tell you that there are three behaviors as far as algorithms are concerned. One is called best case behavior, the other is called worst case behavior, and the third one is called average case behavior. And the corresponding input is called best case input, worst case input, and average case input. चलिए best case input के define करेंगे. Well, first worst case, the input class, look at that. The input class for which the algorithm does maximum work and therefore take maximum time, that is called worst case input, and that corresponding time is called worst case time. और ये बिहेवियर को हम बोलेंगे वर्स्ट केस बिहेवियर. जैसे कि लीनियर सर्च, मैंने अभी कहा लीनियर सर्च का वर्स्ट केस बिहेवियर कब होगा, जब एलिमेंट विल बी फाउंड एट द लास्ट प्लेस मेकिंग ऑल n कंपैरिजंस, या फिर एलिमेंट इज नॉट फाउंड, इट विल आल्सो टेक n कंपैरिजंस. ये हो गया है वर्स्ट केस बिहेवियर ऑफ लीनियर सर्च. बेस्ट केस इज व्हाट, द इनपुट क्लास फॉर विच द एल्गोरिथम डज मिनिमम वर्क एंड हेंस टेक मिनिमम टाइम, दैट इज कॉल्ड बेस्ट केस इनपुट. Linear search का best case behavior कब होगा, the element you are searching for is found at the first place, that is called best case. उसी तरह quick sort behave in worst case for sorted inputs. मतलब अगर आपका input class already increasing or decreasing order हो तो quick sort will behave in worst case, it will take maximum time. Non sorted inputs के लिए quick sort will work in best case, taking less time. दैट इज कॉल्ड वर्स्ट केस एंड बेस्ट केस। फिर ये दोनों केसेस के बीच का केस है एवरेज केस, एवरेज केस, राइट। एवरेज केस विल बी डिटरमिन्ड बाय डिटर्मिनिंग द प्रोबेबिलिटी समेशन, मतलब you have to determine the time for each input class and then the probability of that input class and then take a sum of it। जो हमारा गेट के सिलेबस में we don't have average case, लेकिन डेफिनेशन रिमेंबर कीजिएगा। यहां पर एक बहुत इंपॉर्टेंट पॉइंट आपको कह रहा हूं बच्चों, आपके काम आएगा एग्जाम के लिए, लिख रहा हूं मैं यहां पर। Suppose if I say the worst case time of an algorithm is represented by a function a of n, best case time is represented by b of n, and average case time is represented, sorry, worst case will say w of n, and average case is a of n. Then the relation between these three functions is that the best case behavior time is always less than or equal to average time is always less than or equal to w of n. This is an important relation that you have to remember as far as behavior or types of analysis is concerned. Best case time is always less than or equal to average, average is less than or equal to worst. This is an important conclusion as far as types of analysis is concerned. Then with this background, now we are going to begin our discussion with asymptotic notations. We write in short ASN. बच्चों कहना यह है कि asymptotic notation basically is a mathematical concept, is a mathematical tool. Asymptotic notation is a mathematical tool. ये जो टॉपिक है मैथमेटिक्स की टॉपिक है, मैथमेटिक्स के टेक्स्ट बुक में जनरली डिफाइन होता है। कहना यह है asymptotic notation is used to provide bounds of functions, determine bounds of functions, mathematical functions. A mathematical function can have typically two important bounds. One is called the upper bound, maximum value, and the other is called lower bound, minimum value. You have limiting definitions for this, limits के definitions रहेंगे. As the value of n increases or tends to infinity, what is the maximum value the function can take, what is the minimum value the function can take, you try to determine for functions. तो मैं ये कह रहा हूं कि asymptotic notations is basically a mathematical tool, mathematical concept. Then why are we using in analysis of algorithm? Reason is simple. We are using asymptotic notations in analysis of algorithm for simple reason that our time of algorithm is represented by a mathematical function. तो जैसे ही time represent हो रहा है by means of a mathematical function, I can apply a bound on it to determine what is the maximum time, what is the minimum time for that case of input that the algorithm takes. So therefore, asymptotic notations characterize the time. It is a notation, it is a useful handy tool to characterize the time in different cases. Maximum case, minimum case, and there is a special case called tight bound case, right? So that is a reason for introducing asymptotic notations to characterize the running time of algorithm and represent the time in a suitable, elegant way. Otherwise, my function may have 10 terms, 100 terms, and if I say that the time taken by algorithm is represented by a function having 100 terms, it looks very awkward. So हम अगर characterize करके एक suitable notation से represent करेंगे like order of n square, omega of n cube, something like that, then that makes more sense. So as far as GATE exam is concerned, listen to me, very, very important point. As far as GATE exam is concerned, asymptotic notation is a very important topic. Asymptotic notation is a super duper important topic. Super important topic. एक या दो क्वेश्चंस मिनिमम या 2 से 4 जरूर आएंगे गेट एग्जाम में on asymptotic notation. So therefore, having a profound, crystal clear understanding of asymptotic notation, their definition, properties is primarily very important for both GATE CSIT and GATE DS students. जरूर आपको क्वेश्चन आएंगे asymptotic notation से. So therefore, having a profound knowledge, profound understanding of asymptotic notations is very important. So let's understand what are asymptotic notations. So quickly revise करेंगे definitions, फिर directly problem solving पर आएंगे with regard to asymptotic notations. 2 to 4 questions you can expect, 2 minimum, maximum up to 4. ठीक है, चलिए. So it is basically a function can have 3 bounds. I said upper bound that indicate the maximum time, lower bound that indicate the minimum time. Tight bound will happen in a special case, we will see later point of time. So I classify the asymptotic notations into 2 types, big notations and small notations. There are three big notations, one called big O that gives the upper bound, big omega that gives lower bound of a function that indicate the minimum time case, and theta tight bound case. So it is not like worst and best. So when I say upper bound, it is not like worst case behavior, this is not like best case behavior. The maximum time and the minimum time for that case of input, for that value of input. Small notation, there are two small notations, small o and small omega. This will give you proper upper bound. Now what is proper upper bound and how is it different from regular upper bound, that we'll see later point of time. Generally students यहाँ पर ये पूछते हैं मुझसे कि sir what is the advantage or drawback of these. There is nothing like any advantage or drawback of these notations, please. There is nothing like, there is a drawback of big notation for which you have to go for small notation, nothing like that. It is only a notational convenience, that's it. Just a convenience of notation है. So nothing like advantage or drawback. चलिए understand करना होगा big O notations. Problem solving for asymptotic notations के लिए आपको मुझे एक important बात कहना है कि जब आप problem solve करोगे asymptotic notations के लिए, अगर आज करना चाहोगे तो उसका requirement क्या है बच्चों, ये बहुत ज़्यादा important topic है. Requirements जो है ना वो यहाँ पर मैं लिखूंगा short में. You should be highly or fully knowledgeable with regard to mathematical functions. You should be knowledgeable with regard to mathematical functions. Types of functions like logarithmic functions or maybe polynomial functions, exponential functions. Rate of growth of functions के बारे में मालूम होना चाहिए. मतलब which function is having smaller rate of growth, which is having larger rate of growth. जैसा एक simple बात कहना है. Like if I have one function n and n square, which is having a lesser rate of growth, n is having lesser rate of growth. N square is having higher rate of growth. So we say n is a smaller function and n square is a bigger function. तो आपको ये समझ में आना चाहिए, समझ होना चाहिए कि which is a smaller rate of growth, which is a larger rate of growth, or they have equal rate of growth. ये knowledge बहुत important है for solving problems on asymptotic notation. Second important property is logarithms. Logarithms and their properties. Third important topic is summation series. Summation series बहुत ज़्यादा important है. These two are very very important as far as problem solving is concerned with regard to algorithms. Next important topic जो आपने आना है वो है calculus, like integration, differentiation. Of course matrices will not be used here, but from algorithmic perspective matrix manipulation is also important. Some knowledge of probability and a good knowledge of not for asymptotic but in general for algorithms I am writing. Probability for us for analysis of algorithm this much is sufficient, but for the other topics of algorithm probability आना चाहिए, combinatorics होना चाहिए, knowledge of combinatorics. These are essential things as far as the interference of maths is concerned in algorithms. अगर आपकी mathematics strong हो, you would love to love this subject, that's what I would say. If you are good in maths, if you are strong in maths. तो चलिए start करेंगे definitions with regard to big O notation. As I said, the big O is used to represent or obtain or give upper bound of a function. Upper bound. I used to give a normal example to really understand what is the meaning of upper bound. जब मैं अपनी paid class में generally used to tell, if you are standing in front of a huge building, very large, tall building, so many floors are there. So if some person is standing on floor number 10, then what are upper bound floors? All those floors which are greater than 10 are called upper bound. Floor number 11, 12, 13, 14, 15, up to so many. You don't count, you cannot count, let us say, you have so many upper bound floors. Lower bound floors क्या होंगे? 9, 8, 7, 6, 4, like that, so many lower bound floors. Exactly like that, for a given mathematical function, listen to me, this is a very important point. For a given mathematical function, I can have many upper bound functions. I can have many lower bound functions. So these as per mathematics. लेकिन जब हम ये concept algorithms में use करेंगे, whenever we are trying to find an upper bound of a function representing the time, we should try to find that floor, that function which is closest to the given function. Tight bound, which is closest. Like, which is closest floor to floor number 10, floor number 11 you can say. 12 is also greater, 13 is also greater, लेकिन closest कौन सा है उसमें? 11 है. उसी तरह lower bound में closest कौन है lower bound से? 9 है. Then 8 is also lesser, 7 is also lesser, 6 is also lesser, but closest is 9. So as far as algorithm is concerned, when you are determining the bounds of function, upper bound or lower bound, always keep the point in mind. You should find the function which is closest to the given function. Why? Reason is very simple. When I know that my algorithm can terminate within 30 minutes, I should say 30 minutes. I should not say, no, it can complete within 1 hour. You cannot say it will complete within 1 day. That is logically correct, mathematically correct. Lekin logically, as far as common understanding is concerned, that it does not make sense. अगर कोई मुझे पूछेगा, सर यहाँ से where you are staying, if you want to reach a place by name Abbott's here, for example, how much time does it take? अगर मुझे पता हो I can reach within 30 minutes, so I should say 30 minutes. लेकिन अगर मैं कहूँ, sir you can reach within 10 hours, logically correct है, mathematically correct है, but it doesn't suit to the requirement. So it should be always closest function. So remember that point. So what is the definition of big O? It is not written. I'm going to write it here. If I have a function f of n, I want to determine the upper bound of it. Remember, given a function f of n, you want to find what is the upper bound of it. So सबसे पहले आपको ये बात याद रखनी है. To find an upper bound, you have to discover, you have to find another function g. You have to find another function g, obeying certain properties and characteristics which I put here. So we say like this: f of n is said to be order of g of n. Look at this, order of g of n. If and only if the value of the function f of n is less than or equal to c times g of n, where we say for some c, not all, for some c greater than 0, but whenever n is greater than n naught, where n naught is also a constant, like this. Look at this, less than or equal to, ये है property of upper bound. Again I am repeating, boys and girls, please pay attention for those who are listening to me for the first time. To determine the upper bound of a given function f of n, आपको और एक function discover करना होगा, आपको और एक function find out करना होगा, g of n which satisfy this inequality. तो मतलब I can have many g of n satisfying this inequality. There can be many upper bounds. मैंने example दिया, floor 11, 12, 13, so many. So like that here I can have many upper bound. So this inequality should be obeyed not always, but whenever, for some constant c, not all values, for some constant c, but whenever n is greater than n naught. So if you are able to establish this inequality greater than n naught to infinity, then I say, I claim that f of n is order of g of n. Like for example, simple case, 3n plus 10 and g of n, this is not n to 2n, this is like n square. This is n square plus 2n plus 5. So here I say the value of the function f of n is having lesser rate of growth, this is having higher rate of growth. So ये function greater है, देखिए function smaller है. So f of n is said to be order of g of n. f of n is subset of g of n. f of n is order of g of n. So in terms of set theory, I can say f of n belongs to g of n in terms of this. So there can be many functions g of n which obey this inequality, So that is upper bound case. वैसे ही lower bound. So omega notation will give you the lower bound of a function, and this will be totally opposite to upper bound. Totally opposite to upper bound. This will give you the lower bound. So f of n is greater than or equal to c times g of n. Same conditions. That means the value of f will be greater than g. Look at this example. 3 power n is greater than 2 power n. 3 power n is greater than 2 power n. So therefore we say f of n, which is 3 power n, is omega of 2 power n. We say like this. Just opposite है. And tight bound का concept क्या है? यहाँ पर हम लिखेंगे theta notation. Theta. Proposed by Donald Knuth. This will come as tight bound. क्या मुझे कोई chat box में लिख के बताएगा what is the definition of theta, please? Let me see. What is the definition of theta? Let me see. Who will write? बोलिएगा. Tell in the chat box somebody. What is the definition of theta notation? When will theta come into picture? What is the definition of theta? Write down the definition. Equal नहीं. Equal तो ठीक है, वो तो आपकी understanding है. लेकिन definition जब आप बोलोगे तो कैसा? ऐसा नहीं है, average नहीं है. It is not like average case. No. Theta का definition क्या होगा? Theta का definition ये है. Remember always. F of n is said to be theta of g of n if and only if f of n is order of g of n. It should be order of g of n, and f of n should be omega of g of n. मतलब अगर आप इनइक्वालिटी के पर्सपेक्टिव से डेफिनेशन देखोगे तो वी से दैट c1 into g of n should be less than or equal to f of n should be less than or equal to c2 times g of n. तो बात यहां पर गौर करने की यह है कि g of n is same but constants are different, c1 c2 constants are different. So f of n is greater than or equal to when constant c1 multiplied by g of n but less than or equal to c2 multiplied by g of n. Are you getting my point? Like as an example, if you want to see as an example, if I consider the function f of n is equal to 1 plus n square is less than or equal to 3n square. So this is my constant c1. So by this I say it is order of n square. And if I write the same function, I can say that f of n is greater than or equal to 1 into n square. This is c2. So c1 and c2 are different. So therefore it is omega of n square. Because it is order of n square, omega of n square, so therefore we say it is theta of n square. Theta of n square. That's the point. So these are the three important notations. As far as problem solving is concerned, these three notations you remember that is very well. Proper upper bound का मतलब यह है it will be only strictly less than not equal to proper upper bound. Proper greater मतलब real greater रहेगा, equal नहीं होगा वो. So for small notation difference यही है a is less than. अगर आप asymptotic inequality अगर आप डालोगे analogous comparison, when I say that first point f of n is equal to order of g of n, when I say like this, analogously this means that between two real numbers it is just like a less than or equal to b. Analogously. ये हमेशा याद रख लीजिएगा. Analogous definition as per Kahneman textbook. When I say it is omega of g of n, analogously this means a is greater than or equal to b. When I say for theta, f of n is equal to theta of g of n, analogously this means that a is equal to b. Like that, when I say f of n is equal to small o of g of n, analogously this means a is less than b. This is less than or equal to. Fifth point we say f of n is equal to small omega of g of n. Analogously this means a is greater than b. ये है strictly less than, strictly greater. Strictly less, strictly greater. यहाँ पर less than or equal to, greater than or equal to, ये difference है with regard to big notations and small notations. चलिए अब next अब we'll go theta notation का भी definition हो गया है. Properties. I would like you to please have a closer look at this diagram and try to study the properties of asymptotic notations. I'll just give you 2 minutes of time, right? Make a study of this table. Make a study of this table with regard to properties of asymptotics. Just 2 minutes. So I hope you are able to understand these discrete properties. So let us try to go through it. Reflexive, symmetric, transitive, transpose, symmetry. So बच्चों सुनिएगा यहाँ पर. Because I have less than or equal to, reflexive property is satisfied. Less than or equal to satisfy. Theta means equal, satisfy. Small o, small omega do not satisfy reflexive property. ये बेसिस पर क्वेश्चन आ सकता है, पिछले एग्जाम्स में आया भी है. नेक्स्ट, सिमेट्रिक, ओनली थीटा नोटेशन ओबे सिमेट्रिक प्रॉपर्टी, नो अदर नोटेशन. स्मॉल ओ, ट्रांजिटिव विल बी ओबेड बाय ऑल. ट्रांसपोज सिमेट्री का मतलब ये है, लिसन टू मी, ट्रांसपोज सिमेट्री, if A is less than or equal to B implies B is greater than or equal to A. ये है ट्रांसपोज सिमेट्री. If A is less than or equal to B implies B is greater than or equal to A. तो ये हम असिम्प्टोटिक नोटेशन में कैसे कहेंगे? असिम्प्टोटिक नोटेशन में ऐसे कहेंगे, if f of n is order of g of n, listen to me, if f of n is order of g of n, then it means that g of n is omega of f of n. ये है ट्रांसपोज सिमेट्री. g of n is omega of f of n. So that's why transpose symmetry is satisfied by the first two notations, big O and big omega. There is no meaning of transpose symmetry for theta because it is equal. f of n is theta of g of n, g of n is theta of f of n. theta में applicable नहीं होगी, लेकिन last two में होगा similarly. If I say that f of n is small o of g of n, small o of g of n, it would imply g of n is omega of f of n. Sorry, yeah, omega of f of n. ये है ट्रांसपोज सिमेट्री. So this is with regard to properties. चलिए अब क्वेश्चंस पे आएंगे, एग्जांपल्स लेंगे, प्रैक्टिस क्वेश्चंस लेंगे. बी रेडी, गेयर अप, अपने हैंड्स वार्म अप कीजिएगा टू टेक अप दी प्रॉब्लम्स. कम ऑन, फर्स्ट सिंपल क्वेश्चन, वेरी सिंपल क्वेश्चन. कंसीडर द फॉलोइंग फंक्शन sigma p equal to 1 to n p cube, which of the following is or are true? Come on, answer me, let me see. कौन बताएगा आंसर? MSQ. Come on, test your skills. Test your skills. Sum of cubes of natural numbers, first n natural numbers, क्या होगा आंसर? आपको पता होना चाहिए sum of n terms to g, sum of n terms arithmetic progression, sum of n terms, sum of square, sum of cubes. So this is nothing but n into n plus 1 divided by 2 whole square. Am I right? So which will be order of n power 4, omega of n power 4, and therefore this will be theta of n power 4. ये satisfy होंगे. तो आंसर्स में देखेंगे, is it theta of n power 4? Yes sir. theta of n power 5 नहीं होगा, it is order of n power 5. क्या order of, जब n power 4 function है, it will be order of higher function. Yes, it will be order. So therefore C is also true. Is it not greater than n power 4? Is it not greater than n cube? Yes sir, it is greater. So therefore this is also true. So therefore as an MSQ, very simple question, the correct options are A, C, D. A, C, D. चलिए नेक्स्ट क्वेश्चन, उसका सोल्यूशन भी है यहाँ पर, देख लीजिएगा. सो ए सी डी इज द करेक्ट आंसर, बाद में आप अपने तौर पे देखिएगा. चलिए नेक्स्ट क्वेश्चन वर्कआउट कीजिएगा. नेक्स्ट क्वेश्चन वर्कआउट कीजिएगा. कम ऑन. Answer for Ayush Raj Purohit, your answer, f of n is always order of f of n. f of n is omega of f of n, reflexive property. So therefore f of n is theta of f of n. Simple point है. Simple point है. Come on, answer for this question. Find the value of q in terms of asymptotic notation. Big O में बताइएगा answer. What will be the answer for this? Yes, n power 3 by 2. That is correct. You have to use here basically you will have to use integration आप आराम से यूज कर सकते हो. You should remember the formulas for integral. Integral x power n is nothing but x power n plus 1 by n plus 1. You have to use this property. Here the value of x, so therefore it is nothing but p. It is nothing but p power 1 by 2 plus 1 divided by 1 by 2 plus 1. Going in the range from in the interval 1 to n. So the highest value is n. N power 1 by 2 plus 1 is n power 3 by 2, right? Divided by 3 by 2. So therefore this is nothing but theta of n power 3 by 2, which is nothing but n root n. n root n. ये है आंसर इसका. चलिए आगे बढ़ेंगे. सो यहाँ सोल्यूशन भी है, बाद में आप देख सकते हो इसका. हाँ, ऐसे टाइप के क्वेश्चन इंपॉर्टेंट है. ऐसे टाइप के क्वेश्चन इंपॉर्टेंट है. आई वांट यू टू वर्क आउट दिस. कम ऑन, वर्क आउट दिस. आई विल गिव यू टाइम. There are 8 functions, f1 to f8. Arrange them in increasing order. Arrange them in increasing order. Come on, boys and girls, please do it. I'll give you 2 minutes of time. I will give you 2 minutes of time. Arrange them in increasing order. Don't make mistake. Simple question है, बहुत simple है. ज़्यादा complex नहीं है बच्चों. Come on, come on. People have started working. Other people also, please do it. So let's start. बच्चों जब भी आप इंक्रीजिंग या डिक्रीजिंग ऑर्डर में कर रहे हो ना, तो सिंपल पॉलिसी ये है कि आपने फंक्शंस को कैटेगराइज करना है 2 टाइप्स में, पॉलिनोमियल और एक्सपोनेंशियल. 2 कैटेगरी कीजिएगा, क्योंकि जो डोमिनेंस रिलेशन है, डोमिनेंस रिलेशन जो है फंक्शंस का, डोमिनेंस रिलेशन वो ये है, सुनिएगा. कांस्टेंट्स आर हैविंग लेसर रेट ऑफ ग्रोथ दैन logarithms, lesser than polynomial, lesser than exponential, lesser than exponential. ये आप हमेशा याद रखिएगा. इंक्रीजिंग ऑर्डर्स ऑफ रेट्स ऑफ ग्रोथ. चलिए अब यहां पर देखिएगा, दिस इज पॉलिनोमियल कैटेगरी, ये भी पॉलिनोमियल कैटेगरी है, ये एक्सपोनेंशियल है, दिस इज एक्सपोनेंशियल, n factorial is also exponential, n power n is also exponential. ये भी पॉलिनोमियल कैटेगरी में आएगा, ये भी पॉलिनोमियल कैटेगरी में आएगा. तो सबसे पहले पॉलिनोमियल्स हमें कितने हैं, 1 2 3 4. ये 4 पॉलिनोमियल्स में आपने डिसाइड करना है सबसे छोटा कौन सा है. n log n है, रूट n है, n log n है, राइट. और ये है रूट log n. सो ऑब्वियसली रूट log n इज लेस देन रूट n. रूट n इज ग्रेटर देन log n. तो रूट log n इज लेस देन रूट n. तो सबसे पहले आएगा f7, सबसे छोटा, लेस देन. रूट n आएगा f2, लेस देन. अब ये देखागा n log n है, n log n है, असिम्प्टोटिक रेट दोनों की सेम है, तो आप बोलोगे f1, राइट, f1 इज इक्वल टू f8, असिम्प्टोटिक रेट ऑफ ग्रोथ दोनों की सेम है, n log n, n log n। ये हो गए आपके 4 फंक्शंस, 1 2 3 4, ये हो गए आपके 4 फंक्शंस। धीरज वर्मा, आप डिक्रीजिंग ऑर्डर में कर रहे हो, मैं इंक्रीजिंग ऑर्डर पूछ रहा हूं। तो F7 F2 F1 इक्वल टू F8, या F1 लेस देन F8 भी आप लिखो, कोई बात नहीं, अगर असिम्प्टोटिक ग्रोथ नहीं बोल रहे हैं, ठीक है। फिर लेस देन, अब बात होगी एक्सपोनेंशियल फंक्शंस की, अब बात होगी एक्सपोनेंशियल फंक्शन। देखिएगा 2 पावर n है लेस देन 3 पावर n, n फैक्टोरियल का असिम्प्टोटिक जो टाइम कॉम्प्लेक्सिटी आएगी n पावर n है, ये n पावर n। सो F5 and F6 both are same, n factorial, but the value of F5 is less than n factorial, n power n, right? So जब वैल्यू लेस की बात होगी तो हम इसे यहां पर ऐसे नहीं लिखेंगे n पावर n। सो लेस देन हम बोलेंगे 2 पावर n फर्स्ट, दैट इज F3, F3 is less than F4, is less than F5, is less than F6. So this is our final answer. देख लीजिएगा whether you are right or wrong, ये है आपका आंसर, ठीक है। तो यहां पर देखिएगा वही सॉल्यूशन है, F7 F2 F1 इक्वल टू F8, फिर F3 F4 F5 F6, F3 F4 F5 F6, तो ये आंसर है। चलिए और एक एग्जांपल लेंगे आपके सॉल्व करने के लिए, ये सॉल्व कीजिएगा प्लीज, प्लीज वर्क आउट दिस similar way, please work out as another question as a matter of practice, as a matter of practice, please work out this. Come on boys and girls, please work out the problems. पिछले साल के रिवीजन कोर्स में, ये रिवीजन कोर्स में यही फर्क है कि प्रॉब्लम सॉल्विंग ज्यादा है ये बार। फॉर योर प्रैक्टिस प्लीज। No, you should not write Yash Ukhare, Yash Ukhare. You should not write F6 before F5 because, strictly speaking, n factorial की जो value है, it is strictly less than n power n. It is strictly less than n power n. It is not equal to. It is strictly less than. Remember that. Come on. What is the answer for this? Some people have started giving the answers. मैं just classification करूंगा. This is constant. This is poly category. These also under poly category. Logarithmic है poly category. These also under poly category. These also polynomial. These also under polynomial. ये exponential होगा. These also exponential. These also exponential. These also polynomial. तो सबसे पहले polynomial जो आएगा F1 है, right? F1 है. फिर उसके बाद कौन सा आएगा? कमान log n आएगा. log n is smaller function than log n. फिर उसके बाद आएगा log n whole square. फिर उसके बाद आएगा root n. फिर उसके बाद आएगा n log n, राइट? फिर उसके बाद आएगा n square log n. तो आंसर अगर आप कंपेयर करना चाह रहे हो तो यहां पर है, देखिएगा. टेस्ट योर आंसर्स. F1 is less than F3, F3 is less than F4, F4 is less than F2, F2 is less than 6, 6 is less than 5, 5 is less than 10, 10 is less than 8, and 8 and 7 and 9. You cannot say 7 and 9 are same, 7 and 9. I'm repeatedly telling. Please understand, n factorial is strictly less than n power n. क्यों? क्योंकि n factorial की value है n into n minus 1 into n minus 2, so on up to 1. This is definitely less than n into n into n into n. It is more appropriate to say that n factorial is small o of n power n. Small o, more appropriate. Of course, it is, every small o is big O also, but it is more appropriate to say it is strictly less than. ये जो value है ना, it is strictly less than that. Yes. So that's the paradigm. ये है आंसर. ये आपको होमवर्क की तरह दे रहा हूं. एज अ मैटर ऑफ प्रैक्टिस होमवर्क के लिए वर्कआउट कर लीजिएगा प्लीज. and you can verify your answer in the slide. Slide में answer है, बाद में आप देखिएगा. You can take this as homework and try to work out. As a just practice के लिए मैं यहाँ पर पूछ रहा हूँ. Suppose if I have a function f of n is equal to 2 power 2 into log n to base 2. Tell me the order of this. देखेंगे कितने बच्चे सही जवाब देंगे इसके. Tell me the answer for this. Just to know the properties of log. Yes, 𝐂𝐚𝐿 is correct. What is the answer for this? 2 power 2 log n. This is nothing but log n square. क्योंकि using property of log, this is nothing but log of n square to base 2. And using property of log, exchanging these two, this will become n square. So therefore, the order of n square. Another question I ask before I proceed to the next problem. Suppose if I say f of n is given as n power 1 by log n. What is the order of this? Let me see who will answer. N power 1 by log n is order of dash. Come on, tell me what is the answer for this problem? Is order of how much? N power 1 by log n is order of dash. Come on, boys and girls. Is order of 1. This is order of 1 constant. Why? Because this is nothing but, there are two, the exact value of this is nothing but log n here to base 2. So this will be simplified as 2. The exact value of this expression, which is looking like exponential, but actually its value is 2. It is order of 1. Kaise? You can do it in two ways. One is assume that this is equal to x and then take log of both. You will get the answer as 2. That's very simple to prove. चलिए next question पे जाएंगे. This is again a very simple one. So I will ignore it. Come on, we'll work out this. Come on, tell me the answer for this question. Boys and girls. MSQ. Come on. Very simple question. Let's start. F of n is n log n. Then which of the following statements is or are correct? See on board. N log n, is it greater than n into log n? Yes sir, it is greater than n into log n. This is correct. Is it theta of this n square? बच्चों ये convention यहाँ पे लिख नहीं सक रहे हम n square. Is it theta of n square? No, it is not theta of n square. क्योंकि this is less than n square, but it is not greater than n square. It is order of n log n, perfectly correct. So therefore, answer is A and C. Very correct. Many people gave the correct answer and I'm happy about it. A and C. चलिए next question. Come on, answer me. Answer this. Sunita Divedi. At the end of the session, I will talk about GATE 2026, how to prepare for GATE 2025 and GATE 2026. I'll talk about it. Just right now, solve the problems. Try to solve the problems, boys and girls. You are given that for all f of n is greater than or equal to 0 and g of n is greater than or equal to 0. इसका मतलब ये है as simple as that, both are positive functions. Both are positive functions. If f of n is equal to order of g of n, then g of n is order of f of n. First one, is it true or false? जरूरी नहीं है, less than or equal to का मतलब always उल्टा होना जरूरी नहीं है. f of n is order of n square, but n square is not order of n. So therefore, this is not correct. Not always, sometimes. F of n plus g of n is always order of max. This is a property. If f of n is omega of g of n, then g of n is order of f of n, transpose property. So 2 and 3 are correct. Both 2 and 3. So the correct answer is C. Correct answer is C. Very good. Next question. Come on, work out this. Work out this. थोड़ी complexity बढ़ रही है of the questions. This question is star topic. This question is star question. Let me see how many of you will give me the correct answer. Star question hai. Come on, boys and girls. What is the time complexity of the following code snippet? Assume x is a global variable and statement takes order of n time. And statement takes order of n time. Ayush, Raj, Purohit, I already told your answer. I already told Ayush. Ayush, please listen to me. Ayush, Raj, Purohit. If f of n is a function, by reflexive property, f of n is order of f of n. By reflexive property, f of n is omega of f of n. So therefore, f of n is theta of f of n by reflexive property. So अब यही है आपका आंसर. Come on. पहले आपने इसका रिकरेंस बनाना होगा, रिकरेंस रिलेशन बनाना होगा. टाइम कॉम्प्लेक्सिटी फ्रेमवर्क फॉर एनालाइजिंग रिकर्सिव एल्गोरिथम. सो कैसे करेंगे हम? Listen to me. Some people are saying order of n power 4. Okay, listen to me. सबसे पहले आपने मुझे बताना है in the chat box, what is the recurrence? Listen to me, boys and girls. What is the recurrence? What is the recurrence representing the time complexity of this code segment? देखेंगे कौन सही लिखेगा. What is the recurrence? What is the recurrence representing the time complexity of this code segment? Recurrence relation क्या होगा? मैथमेटिकल रिकरेंस रिलेशन क्या होगा? प्लीज बताइए. जनरली पीपल मेक मिस्टेक. विनय हैड मेड मिस्टेक. तिलक शर्मा इज करेक्ट. कुनल ध्यानी इज आल्सो करेक्ट. चलिए, रिकरेंस कैसे बनाएंगे हम इफ यू अज्यूम दैट द टाइम कॉम्प्लेक्सिटी ऑफ दिस फंक्शन इज गिवन बाय टी ऑफ एन, तो हम कैसे डिराइव करेंगे टी ऑफ एन? सी ऑन बोर्ड. टी ऑफ एन इज इक्वल टू, if n is equal to 1, return 1. So therefore it take constant time for n is equal to 1. Recurrence relations for n is equal to 1. हाँ, जब n greater than 1 होगा तो हम यहां पर आएंगे. n is greater than 1 यहां पर आएंगे, ये else part में आएगा. Statement will take order of n time, यहां पे लिख लेंगे n plus. Now 8 into, यहां पर generally people make mistake, मैं इसे highlight करूंगा. People are bound to make mistake for this. मैं explain कर रहा हूं बच्चों, प्लीज गौर से देखिएगा. 8 into t a of n by 2 मतलब we are not going to basically write like 8t n by 2. No, we are multiplying this with the value of it. So multiplication के लिए constant time लगेगा. So a of n के लिए t of n है, a of n by t के लिए t of n by 2. So this will take simply t of n by 2 plus, यहाँ पर second mistake generally people make, plus n power 4. अगर आप वहां पर n plus 4 करोगे तो गलत हो जाएगा. Time for adding a value is constant. तो मतलब दिस इज सम कांस्टेंट. तो हमारा ओवरऑल रिकरेंस बना t of n is equal to t of n by 2 plus n plus b is just order of n. So therefore I can write my recurrence like this. This is my recurrence. इसका आंसर क्या होगा बच्चों? When you simplify this recurrence, what will the answer come as? बोलिएगा. What will be the answer for this if you simplify? आप ये recurrence को दो मेथड से सॉल्व कर सकते हो. You can solve it either with back substitution. You can always solve it with back substitution, or if not back substitution, you can solve it with master method. You can solve it with master method. Are you getting my point? You can solve it with master method. अगर आपको master method पता हो, if you know the master method, then I can simply apply the case. बाद में मैं master method के cases थोड़ा pen down करूंगा. I'm assuming that you know master method. So here, which case apply using master method? Using master method, which case applies? Case 3 will applies. Case 3. Because n is omega of n power log 1 to base 2, log 1 to base 2 is 0 plus epsilon, is true. Case 3 apply hoga, very correct. So by case 3, listen to me, by case 3, the answer for this is theta of n. By case 3, the answer for this is theta of n. Am I right? So therefore, the answer for this is option A. बोलिएगा, is it clear? Is it clear? Later आप चाहो तो back substitution से भी इसे solve करके prove कर सकते हो it is theta of n. Boys and girls, I am repeatedly telling this type of question is important. This type of questions you can expect in the exam. A recursive algorithm may be given and then you will be asked the time complexity. चलिए next question पे जाएंगे. ये भी important star question है. बच्चों solve करने की कोशिश कीजिएगा. Solve करने की कोशिश कीजिएगा. Star question है. Come on, come on. Do it. Very good, very good. As an MSQ, what will you say? AD. Individually हम workout करेंगे. ऐसे type के question order of g of n. Does it imply that 2 power f of n is also order of 2 power g of n? Is it true? ये जैसा कि example, for example, if I take f of n is equal to n and g of n is equal to n square, then 2 power n is definitely order of 2 power n square. This is true. It's true हो रहा है. लेकिन question is, क्या हमेशा true होगा? For every function will it be true? That we have to understand. So here you have to apply some common sense, some common logic. कुछ functions लेकर करना होगा आपको. Like for example, listen to me boys and girls. If I take f of n is equal to 2n and g of n is equal to just n. So here I can definitely say f of n is order of g of n. f of n is order of g of n. लेकिन बच्चों और कीजिएगा. Now 2 power 2n, 2 power f of n is it order? I'm asking you as a question. Is it order of 2 power n? Is it true? बोलिएगा, is it true? Can I say 2 power 2n? Is it order of 2 power n? Following this property, is it true? No, this is wrong. This is wrong. 2 power 2n is 4 power n. 4 power n is not order of 2 power n. Is not order of 2 power n. So therefore, ये wrong हो गई property. So therefore, this is not always true. चलिए next आएंगे. f of n is order of f of n whole square. This is order of f of n whole square. क्या ये हमेशा true होगा? Like you take this same thing, f of n is equal to n. It is order of n square, true. n square is order of n power 4, true. लेकिन क्या हमेशा true होगा? कोई decreasing function ले लीजिएगा please. कोई decreasing function ले लीजिएगा. For example, you can take f of n, listen to me boys and girls, is equal to 1 by n. ये decreasing function है. Positive है, decreasing है. Now f of n whole square क्या होगा? 1 by n square. So can I say 1 by n, is it order of 1 by n square? No. 1 by n square is a smaller function than 1 by n. 1 by n says all small होगा 1 by n square. So greater function cannot be order of this. This is not possible. This is not possible. So it is not always applicable. मतलब हमारा सही आंसर होगा A is false, B is false. It is just mathematics. It all depends on your mathematical intuition. आप जितना strong होंगे mathematics में, analysis part आप उतना strong कर सकते हो. ये मेरा हमेशा implication है. चलिए next. अब थोड़े फंक्शंस पर आएंगे, जहां पर लूप्स होंगे और रिकर्सिव नॉन रिकर्सिव फ्रेमवर्क्स होंगे। चलिए डिस्कस करेंगे सम क्वेश्चंस, वेरी सिंपल। Return generally, if I say time complexity is T of n, what is T of n order of? Come on, tell me, very simple. T of n order of how much? Can I say it is order of n square? People generally make a mistake here. Is it order of n square or order of 1? Order of 1. Order of 1 hai ye. We are multiplying the values, that's it. Adding and multiplying the value. So therefore this is order of 1. As simple as that. Don't think that this is order of n square and go wrong. Come on, tell me what is the answer for this. Tell me the answer for this. Loop complexities. लूप्स के ऊपर काफी क्वेश्चंस पिछले एग्जाम्स में आए हैं और आगे भी आ सकते हैं लूप्स। द लूप कैन बी गिवन जेनरिकली और मे बी सी लाइक लैंग्वेज, और आप इसको अगर आप चाहो तो ये लूप को पाइथन में भी कन्वर्ट कर सकते हो। देयर इज नो पॉइंट, देयर इज नो डिफिकल्टी। सो यहां पर क्या हो रहा है देखिएगा बच्चों, इनिशियली i इज इक्वल टू 1, नेक्स्ट वैल्यू ऑफ i बिकम 2, नेक्स्ट वैल्यू i बिकम 4, नेक्स्ट वैल्यू i बिकम 8, नेक्स्ट टाइम इट बिकम 16 and so on. So that means these 2 power 0, 2 power 1, next iteration 2 power 2, next iteration 2 power 3, these iteration number. So time complexity is nothing but number of iterations k that it makes. So it goes up to 2 power k. So total iterations are k plus 1. K plus 1 is order of k. So what is k in terms of n? क्योंकि हमें time हमेशा in terms of input size determine करना होगा. So that means the last iteration, we keep on repeating this as long as 2 power k is equal less than or equal to n. As long as 2 power k is less than or equal to n, we keep on repeating. Last time for which it repeats is 2 power k equal to n. So what is k? K is nothing but log n to base 2. So time complexity of this is order of log n to base 2. जनरली जब असिम्प्टोटिक्स में हम रिप्रेजेंट करेंगे तो बेस डज नॉट मैटर, बेस 2 रहने दीजिए, 3 रहने दीजिए, जस्ट फॉर आवर अंडरस्टैंडिंग पर्पज आई हैव रिटन, बट इवन यू कैन जस्ट राइट ऑर्डर ऑफ लॉग एन, नथिंग मैटर, बेस डज नॉट मैटर मच। चलिए नेक्स्ट क्वेश्चन, इसका ये है सोल्यूशन है, ठीक है। नेक्स्ट इसका आंसर बता दीजिएगा प्लीज, एज अ मैटर ऑफ रिजेम्बलेंस टू द प्रीवियस प्रॉब्लम, एज अ मैटर ऑफ रिजेम्बलेंस टू द प्रीवियस प्रॉब्लम, इसका भी आंसर बता दीजिएगा। कम ऑन। Come on, what is the answer for this? Bilkul, this is log a, log n to base 3, right? So this will be like initially the value is 1, next is 3, next is 3 square, 3 power 1, 3 power 0, and so on, 3 power k. The last time, like earlier occasion, it repeats is when 3 power k is equal to log n, is equal to n. So k is equal to log n to base 3. So order of k means order of log n. आप order of log n भी लिख के छोड़ सकते हो, आप base 3 भी लिख सकते हो, there is no problem. चलिए next आएंगे, इसका आंसर बता दीजिएगा प्लीज। टेल मी द आंसर ऑफ दिस लूप। वेरी सिंपल, नो कंफ्यूजन। outer loop is repeating for n times. Outer loop is repeating for n times. Inner loop is repeating for 10 times. So total number of times this loop repeat is n into 10. If you take the order of this is order of n, as simple as that. बहुत simple है, order of n. Don't get confused. चलिए next इसका आंसर बता दीजिएगा please, is important. Star question है, I will mark it. People generally make mistake here. People generally make mistake here. Yes, Ayush, that's right. I'm having cough, that's what I said earlier. come on, people make mistake here. Generally people make mistake, और इसी का थोड़ा वेरिड पैटर्न सॉरी गेट 2023 में भी आया था, सिमिलर क्वेश्चन, और वहां पर कई बच्चों ने मिस्टेक किया। यहां पर भी वही प्रॉब्लम हो रहा है बच्चों, देखिएगा। j is initialized with n while j is greater than 1, I'm having a loop here, I less than or equal to j, j is getting decreased by a factor of 2, j is getting decreased by a factor of 2। अगर आप पिछले प्रोग्राम की तरह या पिछले प्रोग्राम्स की तरह आप मल्टीप्लाई करने की कोशिश करेंगे इस तरीके से, तो यहां पर आंसर नहीं आने वाला है, यू कैन नॉट डायरेक्टली मल्टीप्लाई। तो यहां पर आपने क्या करना है, यहां पर आपने प्रोसेस यूज करना है अनफोल्डिंग प्रोसेस, अनफोल्डिंग प्रोसेस of loops, sequential iterations, unfolding process या sequential iterations करना होगा। मतलब क्या है, सुनिएगा प्लीज, have a look at this, many people are giving wrong answers, Abhay Singh is correct, see on board बच्चों, see on board, initial value of j is 1, the j is n, j is n, this loop, for loop, this loop is repeating for j times, so initial value of j is n, so how many times this will loop, how many times this will repeat, n times. First iteration, this will repeat for n times. First iteration, this will repeat for n times. ठीक है ना? चलिए नेक्स्ट क्या होगा, j is equal to j by 2, मतलब j की वैल्यू क्या बनेगी, n by 2 बनेगी। जब हम बाहर जाएंगे, अंदर जाएंगे, राइट, दिस विल रिपीट फॉर n by 2 टाइम्स, तो टोटल नंबर ऑफ टाइम्स कितने हो गए, n by 2। ठीक है बच्चों, समझ में आ रही है बात, इज इट ओके? फर्स्ट आइट्रेशन n टाइम, सेकेंड आइट्रेशन में ये n by 2 टाइम्स फॉर लूप रिपीट होगा। थर्ड टाइम क्या होगा, दिस विल बिकम n by 4, तो मतलब फॉर लूप विल रिपीट फॉर n by 4 टाइम्स, करेक्ट। नेक्स्ट टाइम क्या होगा, n by 8 टाइम्स, एंड सो ऑन, प्लस n by these 2 power 1, these 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power k. So time complexity is repeating for k times. So total time is nothing but this series. So this is nothing but n into sigma 1 by x, right? 2 power x. One by 2 power I is equal to 0 to k. ऐसे होगा डिक्रीजिंग जीपी। इसका समेशन क्या होगा, इफ यू एक्सपैंड द समेशन टू n टर्म्स ऑफ जीपी, दिस विल कम एज 1 minus 1 by 2 power k। जीपी का समेशन ये होगा। So this get expanded as n minus, n is equal to 2 power k, let us assume without losing generality, so this will become 1, n minus 1 is order of 1 theta of n. So those who said n log n is wrong, those who said log n is wrong, the correct answer for this is theta of n. That's why I said star question. ठीक है, दिस इज द पैराडाइम। चलिए नेक्स्ट क्वेश्चन पर आ रहा हूं मैं, इसका आंसर बता दीजिएगा प्लीज, इसका आंसर बता दीजिएगा। ठीक है, ये क्वेश्चन के बाद मैं फिर से जाऊंगा क्वेश्चन पे, वेरिएशन डिस्कस करेंगे हम, लेकिन पहले इसे सॉल्व कर लेंगे बच्चों। लेट अस सॉल्व दिस। What is the answer for this? द आंसर इज बी। ठीक है, चलिए स्टार्ट करेंगे। For a given value of k, n is t equal to 2 power 2 power k. Again, you should do it using unfolding process. Like I can take, for example, first k is equal to, let us say 0. Or let us say k is equal to 1. Then the value of n will become how much? 2 power 2, 4. N will become 4. Inside loop, so inside loop kitne baar execute hoga? This will get executed how many times? J is equal to 2, look at that. So initial value of j is equal to 2. Okay? 2 is less than or equal to 2. So gate CSIT is present. J is equal to j square. So next value of j will become 4. Right? And then if you go 4 is less than or equal to 4, we print another time. J will become next 16. 16 is greater than 4, I come out. Matlab, for k equal to 1, this is repeating 2 times. This is repeating 2 times. Then if I take k is equal to 2, so total number of times will be n into 2 times. For k is equal to 2, what will n become? 2 power 2 power 2, which is equal to 16. So j will start with 2, it will repeat. J equal to 4, it will repeat. 16, it will repeat. Then after that, it will become 256, you come out. कितने बार execute किया आप? 3 times execute किए. Per iteration of the for loop, we are printing 3 times. Total number of times that it get printed is 3 into n. 3 into n. 3 into n. So that means if you take one more case I will take. K equal to 3, this will become n is equal to 2 power 3, 256. J is equal to 2. J is equal to 4. J is equal to 16. J is equal to 256. It will be true. Then it comes out. How many times? 4 times it has printed. So total number of times n into 4. For loop is repeating for n time. Per iteration it is printing 4 times. Per iteration 3 times. Per iteration 2 times. मतलब हम relation कैसे establish करेंगे? Relation कैसे establish करेंगे? K equal to 1 2 times. K equal to 2 3 times. K equal to 3 4 times. मतलब in general for K, the internal loop will repeat for k plus 1 times, and total iterations will be n into k plus 1, which is nothing but order of n into k. But what is k? Listen here, what is k? If you write n is equal to 2 power k, if you find the value of k, k is nothing but log n. K is nothing but log n. So therefore, the time complexity of this will become order of n into log n. N into log n. So the correct answer is B. N into log n. So this is also a star question, and you can expect similar questions in the exam. अच्छा ठीक है, प्रीवियस क्वेश्चन में कुछ स्टूडेंट्स ने डाउट पूछा था, वो हम यहाँ पर एड्रेस करेंगे. बॉयज एंड गर्ल्स, प्लीज हैव अ लुक. प्लीज हैव अ लुक. लिसन टू मी केयरफुली. Suppose if I don't write j here, if I write n here, quickly tell me what will be the time complexity of this program now if I write I less than or equal to n. Come on, answer me. In the previous program, somebody was asking doubt, so I thought it's a good doubt, let me take up. So if I write this loop going for I is equal to 1 to n, then the overall complexity of this program now will become order of dash. Very simple. The while loop is now repeating for n by 2, n by 4, n by 8. So therefore, this is nothing but log n. Repeating for how many times? Repeating for n times. So total times now it will repeat as n log n. Now it will repeat as n log n. So ये points आपने अच्छे तरीके से remember करना है. This is very important. This is very important. चलिए आगे बढ़ेंगे, next question पर आएंगे. इसका जल्दी आंसर बताइएगा please. This is recursive algorithms. Now we are turning ourselves to recursive algorithms. Time complexity of recursive algorithm. Come on, tell me the answer for this. A recursive function is there. What is the time complexity of this? Formulate the recurrence. Recurrence बनाइए, फिर उसका simplified answer मुझे बताइएगा please. Come on. So suppose if I say T of n is representing the time complexity of this, right? It is equal to constant C for n is equal to 0, you can say, and n greater than 0, I am saying some constant plus some constant A plus t of n minus 1. This is the case where n is greater than 0. If you simplify this is order of n, as many people said. So this is order of n. Next question. Tell me the answer for this. Tell me the answer for this. Correct. That is correct. Tilak Sharma. Tell me the answer for this. What is the time complexity of this program segment? This has been misplaced. So let me write. Time complexity of this program. Yes. Recurrence क्या बनेगा यहाँ पर? Recurrence direct लिख लेते हैं. T of n is equal to, this loop is repeating please, for n times. So n times plus t of n minus 1. If you simplify this order of n square, very correct. ये है order of n square, very correct. Many people gave the correct answer. आगे बढ़ेंगे. इसका बताइएगा please. इसका बताइएगा. Again ये यहाँ पर misplaced हो गया है. What will be the time complexity of this? Come on, these are all warm-up problems. इसके बाद practice questions आएंगे. चलिए. Now the loop is repeating for how many times? This is the loop. The loop is repeating for log n time. So log n plus n minus 1. So t of n is equal to t of n is equal to t of n minus 1 plus log n. तो कैसे एक्सपैंड होगा? बैक सब्स्टिट्यूशन से अगर आप करोगे log n plus log n minus 1 plus log n minus 2 ऐसा आएगा. log n plus log of n minus 1 plus log of n minus 2 and so on. So this is nothing but log of n into n minus 1 into n minus 2 so on up to 1. This is nothing but log of n factorial, which is theta of n log n. Order of n log n, theta of n log n. ठीक है? This is n log n complexity. Next. तो चलिए इस बैक सब्स्टिट्यूशन मेथड यहाँ पे एग्जांपल है. बाद में आप जस्ट टू फैमिलियराइज योरसेल्फ देख सकते हो. नोट्स के लिए है, आपके नोट्स है ये. बैक सब्स्टिट्यूशन से वी आर वर्किंग आउट. So I'll master method का भी I've already told the cases. Generally there are different conventions for master method, right? General master method are general convention. मेरा अपना एक method है, then Corman का अपना एक convention है different. So I believe that I'm not forcing you to follow which method, which you can follow my method or you can follow others' method. Whichever method you want, you can apply. There are 3 cases, so you should be familiar with the 3 cases. कुछ questions लेंगे master method पे. And we'll try to work out. We try to work out. यहाँ पे देखिएगा examples है. Already एक 2tn by 2 plus log n है. This theta of n. We have already worked out. 2tn by 2 plus n log n है by case 3. And here I want you to work out this and tell me the answer. Come on. As a matter of practice. As a matter of practice. Come on. Yes, Tilak Sharma, you can follow my method. You can follow my method. Solve this problem and tell me using master method which case apply and which case is better. Robin Sharma, you can get my notes by asking in my group Telegram channel. Which case applies for this? Which case applies? Is it case 1 or case 2 or case 3? Come on, write down that. Is it case 1 or case 2 or case 3? Case 1. Chaliye. What is case 1? Here I am writing case 1. Can I say that n power half f of n, is it order of n power log a to base b, log 3 to base 4, log 3 to base 4 minus epsilon? Can I say that log 3 to base 4 value is greater than 0.5? Yes, it is greater than 0.5, maybe like 0.8 or something like that. So therefore this is definitely satisfying case 1. Therefore by case 1 I say T of n is theta of n power log 3 to base 4 by case 1. By case 1. So therefore answer is A. Second question workout कीजिएगा. Apply master method. Apply master method and tell me the answer for this question. This is star question. This is slightly important. Slightly important. इसलिए एक स्टार डालूंगा मैं यहां पर. Somewhat important. Come on, do it. यहां पर क्वेश्चन में पूछा जा रहा है मिनिमम पॉसिबल वैल्यू ऑफ आर. मिनिमम पॉसिबल वैल्यू ऑफ आर पूछा जा रहा है प्लीज. सो यू हैव टू टेल द मिनिमम पॉसिबल वैल्यू ऑफ आर. Yes, many people have gave the correct answer. So here I would like to go. I'm checking for case 1. I'm checking for case 1. Can I say that log n function f of n, is it order of n power log a to base b? Log a to base b. Log of n power log of a root 2 to base 2. So it is nothing but half order of n power half minus epsilon. Minus epsilon. For a very small value of epsilon, this is definitely satisfying. For epsilon greater than 0, very small value, log n is less than root n. Log n is less than root n. So therefore, this is perfectly satisfying. By case 1, I say this is order of n power half. So he is asking n power r. R is equal to nothing but half. So the correct answer for this is half. Half is the answer, 0.5. Half, you can write 0.5. The value of r, minimum possible value of r is 0.5. Because minimum पूछा जा रहा है, maximum it can be anything. Maximum it can be anything. Minimum value means it is 0.5. Maximum it can be n. Maximum can be n square, n cube, like that. I hope you are getting my point. So that's why he's asking minimum possible value. Chaliye, next question. Tell me the answer for this. Tell me the answer for this. Come on, work out, boys and girls. What is the answer for this? Yes, the answer is 3 power n. So always remember, if I have the function t of n is equal to 2 times t of n minus 1 plus some constant, then this is always by back substitution order of 2 power n. अगर उसी तरह यहाँ पे 3 t n minus 1 plus constant रहेगा, this you can take it like order of 3 power n. In general, if I write like 4 into t, like order of 4 power n. So this you have to always remember. चलिए next question पे आएंगे. So tree, the other approach of solving recurrences is recursion tree method. अब मैं यहाँ आपको टीच तो नहीं कर सकूंगा, लेकिन नोट्स में बता रहा हूँ recursion tree method. और जो पेड स्टूडेंट से एक बार अच्छी तरीके से रिवाइज कीजिएगा. Recursion tree method, just remember one point as a point. Recursion tree method for solving recurrences is useful for solving asymmetric recurrences. Asymmetric size recurrences. तो जब भी आपको रिकरेंस रिलेशन दिया जाएगा विच इज असिमेट्रिक, साइजेस डिफरेंट हो, राइट, साइजेस डिफरेंट हो, तब यहां पर आप रिकर्शन ट्री मेथड से सॉल्व करना है. जैसे कि फॉर एग्जांपल, इफ आई एम हैविंग ए रिकरेंस ऑफ द टाइप t of n is equal to t of n by 3 plus t of 2n by 3 plus some function f of n. Recurrences of this form, it is always desirable that you solve them using recursion tree method. तो आप एक बार रिकर्शन ट्री मेथड भी अच्छे तरीके से फेमिलराइज कर लीजिएगा. नोट्स में यहाँ पर पूरा डिटेल में बताया गया है. यू कैन ऑल्सो हैव ए लुक एट इट. सो डिफरेंट फॉर्म 2tn by 2 plus c, 4tn by 2 plus c, 3n. ये देखिए इसका सोल्यूशन जो मैं कह रहा था, इसका solution है recurrence. So it is always desirable that for standard recurrences you remember their what are their answers, क्योंकि बाज़ वक्त direct question आते हैं, बाज़ वक्त direct question आते हैं, वो direct question के लिए आप if you remember the answer you can select it very easily. You can select it very easily. यहाँ पर देखिएगा एक table दिया गया है. So this is an important table. Kindly go through this table. Standard recurrences है, उसके solutions क्या है, उसके order of magnitude क्या है, that you can do it here, right? Like t of n is equal to constant for n equal to 2, t of n is equal to 2t root n plus c, this is order of log n, t of n minus 1 plus c, order of n, this is order of n square, and like that it goes. So this table is a useful table for remembering the recurrences and their corresponding solutions or order of magnitude. Finally, bachcho, space complexity, before we take up some practice questions, I would like to tell you that how the space complexity is determined. The space complexity of an algorithm is the time, is the space requirement for auxiliary space, additional space. Input space हमेशा time complexity में determine नहीं की जाएगी. The space complexity always depends on the auxiliary space. Auxiliary और recursive algorithm के लिए stack space. जैसा मर्ज सॉर्ट में we require additional array, ठीक है? और अगर रिकर्शन में आपके साइज ऑफ रिकर्शन क्या है, डेप्थ ऑफ रिकर्शन स्टैक क्या है, आपको डिटरमिन करना पड़ेगा. सो फॉर दैट space complexity is basically determined on the auxiliary space requirement, additional space. Like for example, just as a matter of correlation, tell me the space complexity of these two simple problems. Let me see. Tell me, what is the space requirement of this? There is an array of size a of n, algorithm Rn a comma n. A is an array of size n elements. ठीक है ना? Array की size है n elements. n equal to 1, return a of 1. Otherwise, return a of n plus r sum of a comma n minus 1. This is determining sum of elements of the array. Sum of elements of the given array. Of the given array. आपने टाइम कॉम्प्लेक्सिटी बताना है और स्पेस कॉम्प्लेक्सिटी बताना है. बोलिएगा, चलिए. What is time complexity of this and what is the space complexity of this? Come on, quickly work out and tell me. Quickly work out and tell me. What is the time complexity and what is the space complexity of this? स्पेस कॉम्प्लेक्सिटी भी आ सकता है, हम नहीं जानते. मिस्टर और मिस हम नहीं जानते. स्पेस कॉम्प्लेक्सिटी भी क्वेश्चंस आ सकते हैं और एज एन एल्गोरिथम डेवलपर आपको पता होना चाहिए स्पेस कॉम्प्लेक्सिटी कैसे डिटरमिन करते हैं. जैसा टाइम कॉम्प्लेक्सिटी इंपॉर्टेंट है, स्पेस कॉम्प्लेक्सिटी भी इंपॉर्टेंट है. इसका रिकरेंस क्या बनेगा? इसका रिकरेंस बनेगा t of n इज इक्वल टू t of n माइनस 1 प्लस कांस्टेंट. इसे सिंप्लीफाई करोगे तो टाइम कॉम्प्लेक्सिटी बनेगी ऑर्डर ऑफ n. ऑर्डर ऑफ n. स्पेस कॉम्प्लेक्सिटी विल डिपेंड ऑन द साइज ऑफ द स्टैक, रिकर्शन स्टैक. कितने रिकर्सिव कॉल्स हो रहे हैं? n रिकर्सिव कॉल्स. n, n minus 1, n minus 2, n minus 3 up to 1. So therefore, size of the stack is order of n. So space complexity of this is order of n. ये जो n है, this is size of stack. Size of stack. उसी तरह ये प्रॉब्लम का भी टाइम और स्पेस निकाल के मुझे बताइएगा प्लीज. So what is the time complexity of this and what is the space complexity of this? Come on, tell me. What is the time and space complexity of this algorithm? Yes. Recurrence for time complexity will become t of n is equal to t of n by 2 plus constant. If you simplify this, this will come as order of log n. और depth of stack n, n by 2, n by 4, n by 8 इस तरीके से जाएगी. That is nothing but log n depth. मतलब आपकी space complexity बनेगी order of log n. ये again, this is recursion stack. These again, recursion stack. Space for recursion stack. ठीक है ना? So that is about time and space. अब ये उसका solution यहाँ पे बताया गया है. This is a simple one, you can do it. अब कुछ practice questions लेंगे बच्चों. चलिए, first it is PYQ. Answer it. Come on. सीधा सीधा PYQ है. गेट 2023 का क्वेश्चन है. अगर पहले भी आप कर चुके तो लेकिन सोच समझ के दीजिएगा. शायद हो सकता है मैंने कुछ मैनिपुलेट किया हो ऑप्शंस में. आई डोंट रिमेंबर, बट यू ट्राई टू वर्क आउट एंड टेल मी. इट्स एन इंपॉर्टेंट क्वेश्चन. The definition of f of function 1 is given here. The definition of function 2 is given there. Tell me what is the answer for this as an MSQ. As an MSQ. As an MSQ, what is the answer for this? Now, just now we worked out. If you remember, we have worked out exactly this. We have worked out exactly this. For I is equal to 1 to n. The value of n is keeping on changing, बच्चों. n is initially, so n by 2, then n by 4, then n by 8. हमने इसे work out किया and we have proved that this is order of n. This is order of n. And these also order of n. दोनों functions की complexity order of n है. तो मतलब option से क्या होगा? It is theta, yes it is theta. It is small o, no it is not small o. Is it small omega? No it is not small omega. Is it big O? Yes it is big O. So therefore, the correct answer for this is A plus D. The correct answer for this is A plus D. चलिए next question. इसका बताइए आंसर. What is the correct answer for this? ये भी एक PYQ है. This is also a PYQ. Come on, come on. Don't get distracted, बच्चों. What is happening at other places, that should not be your worry. जो भी होगा होगा. You don't have to worry about it. ठीक है? Concentrate here. This is more important for your career. That is not important. कौन जा रहा है, कौन आ रहा है, कौन कहाँ जा रहा है, कौन कहाँ से आ रहा है. मल्टीपल ऑप्शंस आपको नहीं चाहिए. राइट? ऑप्शन ए कौन कहाँ जा रहा है, ऑप्शन बी कौन कहाँ से आ रहा है. ठीक है? ऐसा आपको नहीं करना चाहिए. जस्ट कॉन्सेंट्रेट हियर. रिवीजन पे फोकस कीजिए. अपना प्रोग्रेस देखिए. पहले अपना प्रोग्रेस इज मोर इंपॉर्टेंट देन अदर्स. come on, what is the answer for these boys and girls? हाँ, पढ़ाई के लिए आसिफ बिल्कुल सही बात है. पढ़ाई के लिए, अपने प्रोफेशनल ग्रोथ के लिए व्हाट इज इंपॉर्टेंट इज सेल्फिशनेस. पहले मैं अगर अच्छा हूं तो फिर आप दूसरों को भी अच्छा रख सकते हो. अगर आप ही अच्छे ना हो तो दूसरों के लिए क्या कर सकते हो. मेरे अपने के गुरु थे, वो हमेशा ये कहते थे, अगर फर्ज करिए कोई बच्चा, कोई आदमी अगर बौली में गिर गया है तो और आपको मदद के लिए पुकार रहा है, आप मदद कब करना चाहिए? मदद आप जब करना चाहिए जब आपको अपना प्रोटेक्शन करने के लिए कुछ सहारा हो, तभी आप अपना हाथ देना चाहिए. एक हाथ देना चाहिए, दो नहीं. अगर दोनों हाथ दे दोगे आप तो आप भी चले जाओगे अंदर. तो इसलिए आप इधर उधर मत देखिए, अपना डेवलपमेंट देखिए. दैट इज वेरी इंपॉर्टेंट. चलिए, एफ ऑफ एन फॉर ऑल पॉजिटिव फंक्शन. देखिएगा बच्चों, यहाँ पे पॉजिटिव फंक्शन एफ ऑफ एन. एफ ऑफ एन स्क्वायर, लाइक फॉर एग्जाम्पल इफ आई गिव एफ ऑफ एन इज इक्वल टू एन स्क्वायर, ऐसा है फंक्शन. सो एफ ऑफ एन स्क्वायर क्या होगा? एफ ऑफ एन स्क्वायर बनेगा एन पावर 4. इज इट थीटा ऑफ एफ ऑफ एन होल स्क्वायर क्या होगा? एफ ऑफ एन होल स्क्वायर, एफ ऑफ एन होल स्क्वायर, एफ ऑफ एन होल स्क्वायर क्या होगा? मतलब एन स्क्वायर होल स्क्वायर विल ऑल्सो बी एन पावर 4. So this is also n power 4, this is also n power 4, theta of n power 4. It is always theta of n. So f of n is always, remember here, it's a polynomial. It is not logarithm. It is not exponential function. It is not decreasing function like 1 by n. ठीक है ना? It is a polynomial function. So therefore, f of n is always theta of f of n square. This will always be true. F of n square is small o. This small o of f of n whole square. This is not always true for every type of function. देखिएगा, यहां पर फंक्शन की टाइप नहीं दी गई. दैट मीन दिस इज एप्लीकेबल फॉर ऑल टाइप्स ऑफ फंक्शंस. आपको टेस्ट करना होगा फॉर ऑल टाइप्स ऑफ एफ ऑफ एन, पॉलिनोमियल, लॉगरिथमिक, एक्सपोनेंशियल, एवरीथिंग. सो इट डज नॉट सैटिस्फाई एवरी टाइम. Now f of n, like for this itself, it is not satisfying. F of n square is equal to big O of f of n square, where f of n is an exponential function like e power n, right? So therefore, this is also not true. These also similarly will not be satisfied. Only option A will always be true. So that's a very simple way of taking. So therefore, the best way of solving such questions is by taking suitable example and solving it. Come on, this, tell me the answer for this. Tell me the answer for this. पॉलिनोमियल का मतलब यह है कि इट इज लाइक ऑलवेज इंक्रीजिंग फंक्शन. पॉजिटिव फंक्शन मतलब इंक्रीजिंग टाइप. ओके, फॉर अ वैल्यू ऑफ n it should always keep on increasing, it should not decrease. Come on, what is the answer for this? Come on, what is the answer for this? So let's start. Outer loop is repeating for n times. This is repeating for 1, order of 1. Now this is log n per iteration, and this is n for this. So therefore, n into 1 plus n into log n plus n into n square. So straight away option is C. Option is C. And B also may be correct. B also may be correct because it is saying order of n square log n. So asymptotically, which are correct means n square log n and n square as far as mathematical definition is concerned. अगर ये question MSQ से पूछा गया, then B and C. अगर MCQ से पूछा गया तो you should select only C. You should select only C. ये बात याद रखिएगा आप. As an MSQ both B and C, and an MCQ only C. Only C. चलिए next question. Tell me the answer for this. Tell me the answer for this. It is important. It is an important question. What is the answer for this? Yes, that is on n log n. That's right. Outer loop is repeating for n times. Inner loop क्या होगा देखिएगा, j is equal to j plus 1. So first iteration this will repeat for n time. Second iteration it will go for j is equal to j plus 1, j plus 2, n by 2 times. Third iteration this will repeat for n by 3 times, n by 4, and so on, n by n. So this is nothing but n into sigma 1 by x, x going from 1 to n. देखिएगा 1 by 1, 1 by 2, 1 by 3, 1 by 4 up to 1 by n. So this, if you simplify, is nothing but order of n into a log n hai. So therefore n log n. Order of n log n. Option C is correct. चलिए next question. Tell me the answer for this. This is a PYQ. Important PYQ है. That's why I'm bringing here. Tell me the answer for this. Come on, what is the answer for this question? Yes, option is D. That's correct. देखिएगा, this loop is repeating for n times. This is order of 1. This is nothing but log of n, right? And then this is repeating for log of p, means log of log n per iteration. Per iteration. So which one of the following most closely approximate the return value of the function for this? So log n plus log n plus log n, how many times? N times. So therefore n into log n, n into log n, that is the time for this. अगर बच्चों यही क्वेश्चन की if I ask, listen to me, यही क्वेश्चन की if I ask the time complexity, can anybody tell me the time complexity of this algorithm is what? Come on, tell me. Tell me please. If I ask time complexity of this, then what will be the answer? The value of q is order of log n. The value of q is order of n into log n. But the time complexity अगर पूछा जाएगा तो क्या हो गया आंसर? The time complexity होगा n into log n. ये डिफरेंस है. टाइम कॉम्प्लेक्सिटी होगी n log n, लेकिन वैल्यू ऑफ q एट द एंड ऑफ आइटरेशन विल बी n into log n. n into log n. ये डिफरेंस है क्वेश्चन में. चलिए नेक्स्ट क्वेश्चन. ये एक इंपॉर्टेंट क्वेश्चन है, वर्कआउट कीजिएगा. थोड़ा डिफरेंट है, थोड़ा अलग है. Let's see whether you are able to work out or not. Come on, tell me. Let me see who will answer. Let me see who will answer this. ये प्रोग्राम सेगमेंट है आपका. गिवन प्रोग्राम सेगमेंट मतलब दिस इज अ प्रोग्राम सेगमेंट. नहीं, आंसर सृष्टि, यू डोंट हैव टू टेल द आंसर लाइक n स्क्वायर n log n और log n. यहां पर न्यूमेरिकल आंसर आना चाहिए. NAT न्यूमेरिकल आंसर टाइप है, NAT है ये. Shinchan is saying answer as 100. Okay. Manish Ojha 100. Vinit Sharma is also saying 100. Parasite is saying 1000. Okay, कैसे करेंगे हम? The time complexity, a priori time complexity, a priori time of this, a priori time is nothing but n square. Listen here. The a priori time is order of n square. ये n by 2, n by 4, order of n square. ठीक है? If the program segment takes 10 milliseconds to run for n is equal to 50, listen now. For n is equal to 50, the asymptotic time will be 50 whole square. Will be 50 into 50, which is equal to, you can say, 2500 units. तो जब ये segment, जब ये program segment, if you are running it on a particular machine, when you are running it on a particular machine, the time is equivalent to 10 milliseconds. तो मतलब 2500 units, asymptotic units, is actually corresponding to 10 milliseconds on a particular machine. On a particular machine. समझ गए बात? कोशिश कीजिए समझने की. This a priori time, this is a posteriori time. A priori time, a posteriori time. On a particular machine 10 milliseconds लग रहा है. तो आप क्या करना है? 1 unit निकालो आप. 1 unit के लिए कितने milliseconds लगेंगे? So 1 asymptotic unit corresponds to 10 divided by 2500, which is equal to 1 by 250. 1 by 250 milliseconds. Highlight कर लीजिए. ठीक है? one asymptotic unit is actually on that machine is equal to 1 by 200, 1 by 250 milliseconds. ठीक है. Now the same algorithm, if it runs for n is equal to 500, input size बढ़ गई 500, तो कितने milliseconds correspond होंगे, कितना time लगेगा? So how long in milliseconds will it take to run for n is equal to 500? मतलब second point now, second point I will writing, second point. For n is equal to 500, the a priori time is nothing but 500 whole square, 500 into 500, which is 25,000, 2,50,000 units. This corresponds to 2,50,000 units for n is equal to 500. हमें पता है 1 यूनिट के लिए इतना टाइम लग रहा है, तो इतने यूनिट्स के लिए कितना टाइम लगेगा? पुट द इक्वेशन. 1 unit is actually taking time of 1 by 250. So 2,50,000 units, 2,50,000 units will take how many milliseconds? So this will give you the answer, which is equal to straight away 1,000. 1,000. So therefore the answer for this question as a numerical type is 1,000. बोलेगा clear है बच्चों? Is it okay? Conceptual questions like this are important. Conceptual questions like this are important. Pay attention to this question. Clear है? Any doubt? Okay, very good. चलिए जल्दी बताइए इसका आंसर. हमने ऑलरेडी देखा. इसका आंसर you can get it like 3t n by 2 means order of n power log 3 to base 2 आएगा इसका आंसर. So you can match it with so this is nothing but 3 power log n to base 2 is nothing but n power log 3 to base 2. So that you will get it as answer. That is a very simple one. चलिए again repetition. आंसर बोल दीजिएगा प्लीज. रिपीटेशन है विथ स्लाइट वेरिएशन. आंसर बताइएगा. आयुष, राज पुरोहित. नो, इट विल बी सेम. It will be same. What are the correct choices for x? Sigma I cube, I equal to 0 to n, sigma I cube. What will be the choices for n? Correct answer for this. Come on. Very simple. This we have already said is order of n power 4 is omega of n power 4 and therefore it is theta of n power 4. तो अब choices match करेंगे. Theta of n power 4 is true. Theta of n power 5 is wrong. Order of n power 5 is omega of n power 5 is wrong. Omega of n power 5. N power 4 is not greater than n power 5. I hope you are on only 1 and 3. Only 1 and 3. 4 is not correct. So यहाँ पर actually एक mistake हो गया है. अगर आप वो mistake avoid करना है with respect to choices, ये n power 5 नहीं है, n cube है ये. So then this will be true. So 1, 3 or 4 but not 2. So option will be C. Option will be C. अगर नहीं यहाँ पे n power 5 लेना है तो only 1 लेंगे आप. Only 1 लेंगे आप. Then that is the thing. Are you getting my point? So either way you can solve. Both the things I told you. ये रिपीटेशन है. थीटा ऑफ n पावर n we already did. I don't want to go. इसका आंसर बता दीजिएगा प्लीज. People get confused with this. Tell me the answer for this question. Come on, do it. Let B of n and A of n respectively denote the best case and average case running time of an algorithm of input size n. Which of the following is always false? Always false. B is best case, is always less than or equal to A of n. This is a relation. B of n is equal to omega of A of n. Definitely true. B of n is theta of W of n. ये W of n नहीं, अच्छा यहाँ पर worst case भी पूछा है. W of n is worst case. Let us write. Not given here. Let us assume W of n is the worst case. Not given. Let us assume. So B of n is theta of W of n. No, no, it is not always true. False. B of n is equal to omega. This is small omega. Omega of A of n. B of n less than or equal to has. So therefore, this is false. B of n is equal to order of W of n. This is always true. Worst case. So therefore, false means C is always false. This may be sometime true. This may be sometime true. Sometimes. Right? This is sometimes true. Because he's saying always false. Right? This is always true. This is always false. That's how you should answer. That's how you should answer. The correct answer is C. Correct answer is C. Small omega. For small omega, it should be B of n is equal to small omega of A of n. B of n will never be greater than A of n. B of n is less than or equal to A of n. So correct answer is C. चलिए नेक्स्ट, ये इंपॉर्टेंट क्वेश्चन है, देखेंगे कौन आंसर करेगा, देखेंगे कौन आंसर करेगा. What does the following function compute? I can transform this code into Python also if you want. You already know Python, DA students. तो आप इसे कन्वर्ट कर सकते हो Python में and then you can do it. क्वेश्चन ऐसा आपको पूछ सकता है. ये कोड को आप Python में लिख सकते हो. C लैंग्वेज फंक्शन है, आप Python में लिख सकते हो और आप क्वेश्चन पूछा जा सकता है. यही फर्क है. ऐसा नहीं है कि पाइथन में टाइम कॉम्प्लेक्सिटी अलग होगी, स्पेस कॉम्प्लेक्सिटी अलग होगी, नहीं. एल्गोरिथम में यू नीड टू लर्न टाइम एंड स्पेस कॉम्प्लेक्सिटीज एंड देन यू कैन इवैल्यूएट द टाइम एंड स्पेस कॉम्प्लेक्सिटी ऑफ ए सी फंक्शन और मे बी ए बेसिकली Python function or Java or any other language. Okay. So Jaskaran Singh, that's right. What does this function compute? This function compute nth Fibonacci number. If you try to see nth Fibonacci number, nth Fibonacci number. So Fibonacci series आप compute कर सकते हो with respect to this code. चलिए नेक्स्ट क्वेश्चन पे जाएंगे. इसका आंसर बता दीजिएगा प्लीज, इसका आंसर बता दीजिएगा. कम ऑन फास्ट. ओके, few more are there. We'll complete this. Come on, do it fast. The following function recursively determines whether a given string is palindrome or not. Determine the time complexity. A simple code hai to determine palindrome. Again, you can implement this in Python if you want. So what is the time complexity of this? Let me see who will answer. Come on, what will be the recurrence for this? What will be the recurrence for this? Come on, tell me what will be the recurrence for this. T of n is equal to less than or equal to 1 return. So therefore constant for n equal to 1 equal to constant time a plus, again constant time comparison b plus, right? Then I say we are calculating this T of n minus 2. So my recurrence is becoming like T of n is equal to T of n minus 2 plus a plus b is a constant d. This is my recurrence, boys and girls. ये जो recurrence बनेगा प्रॉब्लम का T of n minus 2 plus d कांस्टेंट. तो नेचुरली जब आप इसे सिंप्लीफाई करोगे, द सिंप्लीफिकेशन ऑफ दिस विल टर्न आउट टू बी ऑर्डर ऑफ n. Turn out to be order of n. So therefore, the time complexity of this is order of n. Time complexity of this is order of n. चलिए नेक्स्ट क्वेश्चन पे जाएंगे. इसका आंसर बता दीजिएगा प्लीज. रिकरेंस पूछ रहा है of this problem. What is the correct recurrence for this problem, for this segment, recursive program segment? Come on. Void ABC in 10, int x equal to 0, if n is greater than 1, this function, otherwise return. So what will it be? Yes, that's right. So this will make t of n minus 1, because this is t of n. This will be t of n minus 1. And this part, listen to me, this part will be order of n. Will be order of n. So therefore, t of n minus 1 plus t of n minus 1, 2t n minus 1 plus order of n. So correct answer is C. Correct answer is C. Chaliye, next. Tell me the answer for this. Tell me the answer for this. This is called general problem solving. जनरल प्रॉब्लम सॉल्विंग. ऐसा भी आपको क्वेश्चन आ सकता है. तो दोज ऑफ यू हु डू कॉम्पिटिटिव प्रोग्रामिंग, ऐसे क्वेश्चंस आप जनरली प्लेटफॉर्म पर देख सकते हो, लाइक लीड कोड है और मे बी हैकर रैंक है, हैकर अर्थ है, एक्सेट्रा. सो कैसे सॉल्व करोगे इसे? देयर इज एन अरे इन इंक्रीजिंग ऑर्डर. एक अरे है जो इंक्रीजिंग ऑर्डर ऑफ एलिमेंट्स है, उसमें दिस अरे ए 1, 2, 3, etc. n elements. It is in increasing order. Okay. The algorithm to determine indices I and j such that a of I plus a of j is equal to m, a given integer. क्या दो इंटीजर्स है अरे में जिसका सम होगा m, जिसका सम होगा m, ये इंक्रीजिंग ऑर्डर में है. I ask one question, boys and girls. If you try to solve this problem using brute force, if you try to solve these questions using brute force, can anybody tell me what will be the time complexity? अगर आप brute force से solve करोगे, listen to me, listen to me. If you try to work out this question using brute force method, मतलब दो loops लेकर करना पड़ेगा ना, एक I के लिए, एक J के लिए, right? So what will be the time complexity? Brute force के लिए दो loops लेने से आपकी time complexity बनेगी n square. लेकिन क्वेश्चन ये है कि क्या हम एक ही लूप से विथ वन लूप एज एन ऑप्टिमाइज एल्गोरिथम, विथ वन लूप कैन आई डू इट? इफ आई कैन डू इट, देन व्हाट विल बी द मेथड? द मेथड इज लाइक योर बाइनरी सर्च, टू पॉइंटर कॉन्सेप्ट. टू पॉइंटर कॉन्सेप्ट ऑफ बाइनरी सर्च, लाइक दैट यू कैन यूज. अगर आप टू पॉइंटर कॉन्सेप्ट से यूज करोगे, राइट, वर्कआउट करोगे, देन द टाइम कॉम्प्लेक्सिटी ऑफ दिस विल कम आउट टू बी ऑर्डर ऑफ n. टाइम कॉम्प्लेक्सिटी अगर एक लूप में टू पॉइंटर एक आई वैल्यू इनिशियलाइज टू द फर्स्ट एलिमेंट, जे वैल्यू इनिशियलाइज टू द लास्ट एलिमेंट, कंपेयर देम, ए ऑफ आई प्लस ए ऑफ जे इज इट इक्वल टू एन, ग्रेटर देन एन, लेस देन एन. बाइनरी सर्च में जैसा करते हो आप, अगर इफ इट इज ग्रेटर देन, ये वैल्यू सब्ट्रैक्ट कीजिए, इफ इट इज लेस देन, ये वैल्यू इंक्रीज कीजिए, लाइक बाइनरी सर्च. हाँ, प्लेसमेंट्स में भी आपको ये हेल्प करेगा. तो अगर टू पॉइंटर कॉन्सेप्ट से प्रॉब्लम अगर आप सॉल्व करोगे, एक ही लूप लगेगा, ऑर्डर ऑफ n. So therefore the correct answer is linear polynomial time, order of n. Best possible algorithm, the most efficient algorithm is order of n. तो ऐसे क्वेश्चंस भी आप थोड़ी प्रैक्टिस कर लीजिएगा. चलिए जल्दी इसका आंसर बता दीजिएगा. ऐसे जनरल क्वेश्चंस भी आ सकते हैं. लॉग n नहीं होगा आयुष, you cannot do it in log n. Best possible is order of n. सॉर्टेड है तो आप सर्च नहीं कर रहे हो ना, यू आर डिटर्मिनिंग द वैल्यूज ऑफ आई एंड ए ऑफ आई एंड ए ऑफ जे. गौर करके देखिए आप, इज इट पॉसिबल? टेल मी द आंसर फॉर दिस क्वेश्चन. वेरी सिंपल एंड इंटरेस्टिंग क्वेश्चन. अंकित 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 लेखारजानी, द बेस्ट वे ऑफ गेटिंग लॉजिक फास्ट टू वर्क आउट सच प्रॉब्लम इज प्रैक्टिसिंग. प्रैक्टिस कीजिएगा by taking some platform like lead code or platform like hacker rank, hacker earth and so on. You can solve them by doing a lot of programming, competitive programming, and get the proficiency. Geeks for Geeks पे भी कर सकते हो आप, no problem. What is the answer for this? Anybody? Let us read the question. Consider recursive algorithm for sorting an array of n greater than or equal to 2 integers that works as follows. If there are only 2 elements to be sorted, compare them and swap them if they are out of order. So for n is equal to 2, constant time is taken, order of 1. Otherwise, do the following. Recursively sort the first n minus 1 element, t of n minus 1. If the resulting array recursively sort the last n minus 1 elements, right? In the resulting array recursively, so last n minus 1 element, so again t of n minus 1, t of n minus 1. In the resulting array recursively sort the first 2 elements of the array, constant time. तो आपका recurrence बनेगा t of n is equal to 2t of n minus 1 plus constant time. इसका solution है order of 2 power n. So the correct answer is D. Correct answer is D. Correct answer. Questions like this are important. तो इसे मैं आपको star mark करके छोड़ूंगा. Right? So that if a question is directly asked like this, you should not be in a you should be in a position to work out. You should be in a position to work out. It's a star question. ऐसे टाइप के क्वेश्चंस आप एक्सपेक्ट कर सकते हो. वेरी गुड. तो बच्चों ये है प्रॉब्लम्स विथ रिगार्ड टू टाइम कॉम्प्लेक्सिटी, asymptotic time complexity, a priori analysis, and regarding recurrences, recursive framework, non-recursive framework, loop complexity, asymptotic notation, सारे के सारे हमने काफ़ी अच्छे काफ़ी प्रॉब्लम्स किए हैं. You practice this, that should be sufficient enough. अब नेक्स्ट बारी होगी डिज़ाइन स्ट्रैटेजीज की. जो फर्स्ट डिज़ाइन स्ट्रैटेजी इज डिवाइड एंड कॉन्कर. एक ब्रीफ इंट्रोडक्शन लूँगा, फिर उसके बाद प्रॉब्लम सॉल्विंग हम नेक्स्ट उसमें करेंगे, क्योंकि ऑलमोस्ट 2.5 आवर्स हो चुके हैं. आई एम गेटिंग स्ट्रेस्ड because of my health issue. So just introduce karunga topic divide and conquer की, and then we will continue problem solving or divide and conquer, greedy method, dynamic programming, and other things. Yes, Shreshth Chaudhary, I am going to break the session now. So boys and girls, divide and conquer is essentially a strategy which is used for solving problems. Whose input size is large. Problem size become large and complex. Better way of solving it is by dividing the problem into subproblems, into further subproblems until the subproblem becomes small. तो प्रॉब्लम को आप डिवाइड करते जाइएगा until it becomes small. General definition of a smaller problem is you should be able to solve it in few steps, 1 or 2 steps. तो स्मॉलर प्रॉब्लम्स को आप कंबाइन कर सॉल्व कीजिएगा, combine the results, and you keep up combining until you get the solution to original problem. So this is basically a divide and conquer ideology. Many time real life we apply divide and conquer. और मैं आपको ये कहना चाह रहा हूँ कि best design strategy for gate problem, preparing for gate preparation is a problem. उसकी best strategy है divide and conquer. उसकी best strategy है divide and conquer. Generally I tell like that. Shoaib Sheikh is asking something unusual question. ठीक है? That question I cannot answer. So best strategy is divide and conquer for gate preparation. पहले 12 सब्जेक्ट्स है, आप डिवाइड कर लीजिएगा कौन से सब्जेक्ट्स टफ है, कौन से सब्जेक्ट्स लेसर टफ है या डिफिकल्ट है. फिर डिफिकल्ट सब्जेक्ट्स को और डिवाइड कर लीजिएगा, फिर सब्जेक्ट्स को टॉपिक्स में डिवाइड कर लीजिएगा. तो इस तरीके से अगर आप करोगे देन प्रिपरेशन फॉर गेट बिकम इजी. ठीक है? तो और देखिएगा बच्चों, लास्ट पॉइंट ये कहना चाह रहा हूं कि गेट 2024 जो लिखने वाले हैं बच्चे, अब वो लोग तो ज़्यादा कुछ भी मत सोचिएगा आप. यू जस्ट कॉन्सेंट्रेट ऑन रिविजन एंड बेसिकली PYQs. डोंट वरी इफ यू आर गेटिंग लेस मार्क्स इन टेस्ट सीरीज ऑफ वॉट एवर. टेस्ट सीरीज आई एम रिपीटेडली टेलिंग should be taken only for the purpose of time management and testing your level of preparation. That's it. If you are getting less marks, more marks, don't worry about it. Just focus on your revision and PYQs. And those students who are preparing for 2025 or 2026, please start with basic courses like introduction to computers, programming in C, digital electronics, digital logic design, उसके बाद data structures, फिर उसके बाद CO, TOC, फिर operating system, CO, etc. like that. Okay. Simran Singh, dynamic programming can be both recursive and non-recursive. Top-down approach is recursive, bottom-up is non-recursive. 50 marks पे IIT मिल जाएगा. हाँ, new IITs you can get. New IITs you can get. Vicky, yes, I already told. In divide and conquer, sub-problems are always independent. Sub-problems are always independent. Nishu Kumar, I'm telling you, new IITs you can expect with 50 marks, but try to target for 60 plus marks, 60, 65 like that. 60, 65 if you try, then I'm very sure you can get into older IITs. ठीक है? चलिए, और कुछ questions अगर हो तो बोलिएगा please. So don't lose your heart. Don't try to get tensed with regard to GATE exam coming for forthcoming exam. Just maintain silence, maintain peace, calm and composedness, and try to basically concentrate on frequent, constant revision along with PYQs. ठीक है? And don't try to solve so many mock tests. Otherwise, you will get demotivated. You'll get demotivated. So that's it from my side for today's session. In part 2, you will come to know, you can come to know later. We'll discuss the remaining topics of both operating system as well as algorithm. Okay. So thank you very much. I thought of actually taking up divide and conquer, but because of health issue, I cannot further continue. Already more than 2.5 hours we completed. So take care, my dear students. God bless you. And I hope that you sincerely work with good efforts. And I pray sincerely for your grand success. Thank you so much. Take care.